Good morning, everybody. Very good morning. Just a minute, guys. Am I audible to you? Just give your comment. Audible, visible. Very good morning. So, welcome to the marathon session on sequential circuits. The complete sequential circuits, I am planning to cover it in 3 hours. So, let's talk a few facts. Suppose if you take the sequential circuits topic, sequential circuit topic में at least it requires 20 hours to complete the sequential circuits completely. Completely sequential circuits complete करने के लिए हमको कम से कम 20 घंटा लगेगा. मेरा क्रैश कोर्स में देखो I took around 16-18 hours. In the regular course minimum 20 hours I will take it. But here in 3 hours I want to cover the total sequential circuits. So इसका intention क्या? So अगर रेगुलर सेशन है तो व्हाट इज द डिफरेंस बिटवीन दिस मैराथन सेशन एंड रेगुलर कॉम्प्रिहेंसिव कोर्स? रेगुलर सेशन में मैं क्या करेगा? रेगुलर सेशन आई विल डिस्कस वेरी क्लियरली व्हाट इज द रीजन बिहाइंड एवरी सिंगल लॉजिक. उस केस में आई विल डिस्कस व्हाट एंड ऑल्सो why this is happening, why not this, all those things we will be discussing in the regular class. But here I will discuss the facts, but I may not give you the complete reasoning analysis. So these 3 hours will help you to know what's happening in all sequential circuits, what are the problems you will get, so you will get a complete picture. So all those things I will discuss in just these 3 hours. So let's start. So this is about me. This is Bhima Sankar. I did my MTech from IIT Kharagpur. I have around 10 years of teaching experience in GATE and ESE throughout the country. I am expertised with the subjects of last 10 years. I spent my total time on only these 2 subjects, that is network analysis and digital circuits, other than my research. Okay. So I know generally where people feel difficulty, so I will stress more on those topics and how to teach to the students who are from very zero level of the knowledge. So let's go. So this is our total team. They have given you the best quality output to you in the form of video lectures and the notes. Everything is available in our YouTube Kreatryx channel. You can go through it. So if you have not yet downloaded Unacademy app, please do it now itself, because this is a dedicated learning app. Whatever we are taking in the YouTube class, which are completely free, but there are some restrictions in the YouTube because it is not a dedicated learning app. There are some limitations, you can say. But if you download the Unacademy learning app, it is what we can say, it is a dedicated learning app and the best interactive learning app. So for that you need to take plus subscription. You have the free courses in our Unacademy learning app also. Free quizzes are there. You can access everything. If it asks for the code, you can apply the coupon code for free classes also. Other than the free classes, we are providing 2 kind of platforms, that is Plus and Iconic, which are lowest possible cost for the best quality we are providing. If you take Unacademy Plus subscription, you have multiple advantages like daily live classes, morning and evening, structured schedule which will complete on time. You have multiple batches like crash course, rank improvement batch, comprehensive course, everything is available. You need not pay it for again and again. Once you join, you are eligible for all the courses of Unacademy. That is, you can watch any class any number of times without any restrictions. And also, we have the classes in 2 languages, that is English and Hindi also. And you have regular practice के लिए weekly exams are there, monthly exams are there. You have the exams in subject wise, topic wise, monthly wise, and also total pre-vacu questions are available for your practice. And regular doubt solving sessions will be there. After every 3 sessions, 1 session is dedicated for doubt solving. All these are the benefits of the Plus subscription. If you go for Iconic, you will get extra advantage. What is that, sir? You will be provided with a personalized digital coach. who will guide you to reach your destination in a personalized way. He will take you to your destination in a personalized way by planning your study, by analyzing your performance, and also providing the preparatory study material. So you will be assigned with one digital coach. He will or she will take care of you. So these are the price plans for Unacademy Plus subscription for 1 month, 3, 6, 12, 18 to 24 months. If you go for 12 months, originally it is 30,250, but if you apply my coupon code, you will get 10% discount, that is Shankar 10. If you apply it, you get this for 27,225, this for 39,600, this for I think 34,600. Let's check it. So if you apply the 34,650, if you apply the coupon code, in this also you will get the discount. In any course of Unacademy, it's not for my class, it is for total GATE and ESE subscription. These are the 1 year and 18 months and 24 months ka fee. After applying the coupon code, you will get it for this particular price. If you go for Iconic, originally this is the price for 1 year and 2 years. Apply the coupon code. If you like my teaching, if you want to join, if you or your friend, anybody want to join the Unacademy, you can refer my coupon code. Then you will get this for 5,000 discount. Here you get 7,400 discount, and these are the final prices after discount. Okay, fine. So you can follow me on Unacademy for my regular free classes. I have taken few free classes already in this month. You can get the notifications and all if you follow my profile name in Unacademy. You can message there also for any kind of queries. Right, these are the best batches plus batches taken by our top educators of the country. All top educators of the country are now available in Unacademy Plus platform. So if you take the plus subscription, you can attend all the batches, or you can select any one of them according to your requirement. Right. So let's start the class, guys. Why to delay it? So आज का class, I will ask you one thing. Tell me, shall I continue the class in Hindi, English? मेरा पास एक और एडवांटेज है, बाइलिंगुअल. बाइलिंगुअल का मतलब क्या सर? आई विल टेक एवरी सिंगल सेंटेंस इन बोथ द लैंग्वेजेस. ओके, हिंदी में एक्सप्लेन करेगा, देन आई विल एक्सप्लेन इट अगेन इन द इंग्लिश सो दैट एवरी सिंगल स्टूडेंट इज एबल टू लर्न. सो टेल मी योर चॉइस. कॉमेंट गाइस, व्हाट इज योर चॉइस? आई विल गो बाय मैक्सिमम. कॉमेंट. Sanjay Verma, bilingual, any language is fine. So let's rule out English. No option, no student has opted for English. Ramakrishna Reddy, English. Okay, then I will go bilingual so that everybody will be able to understand. So पहले मैं हिंदी में explain करेगा, then I will explain it in English also. So it will be bilingual, guys, so that every single student is able to learn irrespective of their language background. Okay. So आज class का lecture plan क्या है? What's the lecture plan of today's class? Let's see. See here. In the lecture plan, we have today 3 things: flip-flops, registers, counters. 3 thing है क्या? Flip-flops, registers और counters. Total 3 hours में I may spend 1 hour here. इसमें some half an hour of time. ये तो plan है. It may be dynamically change according to requirements. So 1.5 hour. सर इस क्लास में क्या क्या मिलेगा सर? सो पहले मैंने थोड़ा सा थ्योरी देता हूँ. आई विल गिव यू जस्ट ए सिंपल थ्योरी, नॉट कंप्लीट थ्योरी. ठीक है. सो सिंपल थ्योरी कैसा होता है सर? हम कॉम्प्रिहेंसिव कोर्स में क्या किया, सीक्वेंशियल सर्क्यूट में फ्लिप फ्लॉप डिस्कस करना चाहिए तो फ्लिप फ्लॉप स्टार्टिंग से लैच से शुरू किया, एवरी सिंगल लॉजिक डिस्कस करके फ्लिप फ्लॉप का ट्रूथ टेबल तक पहुंचा. When we discuss the comprehensive course, whenever I discuss the sequential circuits, what I did, I started from the very scratch and I take you up to the truth table. Now, because it is a marathon session, what I will do, I will take the flip-flop, I will give you truth table, characteristic table, excitation table, finish. Then we will move to the problems. Okay. So, registers also same thing. Then counters. Counters in the sense here we will discuss everything. सारे synchronous discuss करेगा. We will discuss every synchronous part. Total synchronous part इसमें discuss करेगा. पूरा synchronous part. That is all synchronous circuit का problems. So less theory, more problems is the motto of this class. It will give you like a quick revision in 3 hours for the total sequential circuits, believe in me. So let's start with the flip-flops. So पहले वाला heading क्या सर? SR flip-flop. Let's start. Okay. Let's start with the SR flip-flop. SR flip-flop का points क्या क्या याद करना, what you need to remember, everything I will discuss now. See here. In the SR flip-flop, what is the truth table? So if you wait for just 15-20 minutes, we will start with the problems of all flip-flop circuits. So this is your clock S R Qn plus 1. So what is the condition, sir? When clock is 0, whatever may be the inputs, it will stay in the previous state. What is this, sir? I didn't understand. In SR flip-flop, you have two inputs, S and R, set and reset we generally call. So when the clock input is 0, whatever may be your S and R, it will be staying in the output will be in the no change condition. It will be in the previous state only. When it is 0, 0 also, it will stay in the no change. 0, 1, your output is 0. 1, 0, 1, 1, 1, it is unused, invalid. Okay. So this is the truth table of SR flip-flop. Then what is the characteristic table of SR flip-flop? Very quickly I am revising. So you can use these notes for your revision also. Characteristic table of SR flip-flop क्या होता है sir? S, R, Qn. So what is the meaning of characteristic table, sir? If I am having these as my inputs, what will be the next state? If this is the present output, what will be the next output? So here you can take all the combinations from all zeros to all ones. Let's copy it, we can use it later. Okay. So here what happens, sir? Listen. As per the truth table, when it is 0, 0, no change, 0, 1, invalid. Same you take it here. Here 0, 1, invalid. Okay. Here what happens, sir? No change means whatever you have in the present, same will come in the next. If you solve this by K-map, what is the characteristic equation you will get is S plus R bar Qn. Okay. Solve by K-map. We are not doing that. Right. This is your Qn plus 1 equation. Okay. This is called the characteristic equation of the flip-flop, which will help to find your response for any given input, except it is valid if S into R not equal to 1. Not for 1, 1. Other cases may it is available. It is valid. Next. Excitation table. So you people are waiting for problems. I hope I will be coming to problems in few minutes. Just wait for some time. So please listen. Excitation table is nothing but input. Presently you have this. Next you want this. What are the inputs to be given? Presently suppose I have 0. Next I want 0. What are the inputs to be given for SR flip-flop? मेरा present 0 है, मेरा next output 0 है, मेरा input में क्या क्या देना चाहिए SR flip-flop में इस condition achieve करने के लिए. So मेरा पास 0, next state में 0 चाहिए, I have 0, next state I want 0, what to do? इसके लिए क्या करना? Listen here. Present 0, next also 0. You can give two cases. present 0. Next also if you want 0, you can give here S and R में no change condition, or whenever you need output में 0 you can give 0 1. Two cases में this is possible. This you can write it as S must be 0, R can be any value, right? Similarly for 0 1 you can say you should give 1 0. Okay, to you have 0 next state में 1 चाहिए तो you should give 1 0. Similarly presently 1 next 0 चाहिए तो you should give 0 1. Present 1 next 1 है तो here also it is no change and 1 0 can be given, so you can say it is a cross 0. This is the excitation table of the SR flip flop. This is a quick revision of the SR flip flop possibility. Okay, so let's move. Very good, very good, very good. चलो, yes सौरभ, इंग्लिश में चलेगा. नेक्स्ट वाला इंपॉर्टेंट फ्लिप फ्लॉप क्या है सर? जेके फ्लिप फ्लॉप साहब. जेके फ्लिप फ्लॉप साहब बहुत इंपॉर्टेंट है क्योंकि इनके पास सारे फ्लिप फ्लॉप ट्रूथ टेबल का कंडीशंस इनका फ्लिप फ्लॉप ट्रूथ टेबल कंडीशन पे है. सो लेट्स डू इट फास्टली. आप लोग कमेंट कर सकते हैं. यू कैन डू द कमेंट एज यू नो द ट्रूथ टेबल. जे के क्यू एन प्लस 1. दिस इज योर क्लॉक. So yes guys, you can give the comment. When clock is 0, ठीक है. चलो 0 0 0 to 1 1. आपको पता है ना, व्हेन क्लॉक 0 है तो इनपुट कैन बी एनीथिंग, ये तो नो चेंज में रहेगा. क्लॉक 1 समय में क्या होता है सर? 0 0 में नो चेंज, हियर 0 1 एंड क्यू एन बार. इसमें नया केस आया टॉगल कंडीशन विच इज इनवैलिड इन द प्रीवियस केस. सो हाउ टू मेक ए जेके फ्लिप फ्लॉप सर? हाउ टू मेक ए जेके फ्लिप फ्लॉप? You can see this is, suppose this is your SR flip flop. Q bar, right? This is your clock. So here we will use two AND gates. And here we give J and K. ये तो ऐसा काम करेगा. So JK flip flop में if you take the level triggering, what is the disadvantage? So whenever both the inputs are 1, output will change from previous value to next value. If there is a chance of changing more than once in a single clock, इसको क्या कहते हैं? Race condition. To avoid that, we go for edge triggering or what we call master slave JK flip flop. We will go to that. Before that, see here. So JK flip flop का कैरेक्टरिस्टिक टेबल. J K Q N plus 1. आपको पता है ना 0 0 में what is the answer? 0. Q N here 0 here 1. इसमें क्या सर? Q N bar. This is Q N bar. से अभी देखो. So इसमें Qn ले लो. Here you should take 0, here you should take 1, here Qn bar. Qn bar का मतलब क्या होता है? 0 हुआ तो 1 होता है, 1 हुआ तो 0. What is the meaning of Qn bar? If it is 0, it will become 1. If it is 1, it will become 0. That's all. Now, if you write the characteristic equation by using K map, you get J Qn bar plus K bar Qn. You can use it for finding any information about the flip flop. चलो 1 मिनट. इसका एक्साइटेशन क्या होता है? इसका एक्साइटेशन टेबल थोड़ा सा क्विक रिवीजन कर रहा हूं मैंने. कुछ गलत किया। QN प्लस 1 J और K 0 0 0 1 1 0 1 1, सो 0 क्रॉस 1 0 1 प्रेजेंट 1 1 देना चाहिए, नहीं है तो 1 0। You can give 1 1 or 1 0. So this must be 1, it can be anything. Right. So this is a quick revision of JK flip-flop. So to avoid the race condition, we take the help of master slave. Master slave जी का काम क्या सर? मैंने बताया, it will convert any flip-flop, any level triggered flip-flop converted into edge triggered flip-flop. To convert the level triggering into edge triggering, हम master slave flip-flop का help ले सकते हैं, ठीक है? So it is not only for JK flip-flop, it for any flip-flop master slave configuration में क्या होता है सर? एक flip-flop master जैसा काम करेगा, इसका आउटपुट में दूसरा flip-flop होता है slave जैसा काम करेगा। दोनों का क्लॉक कैसा देता हूं? ऐसा देता हूं। One is given directly clock, another is given through inverter, right? So toggle flip-flop, let's discuss the next one, toggle flip-flop. So T flip-flop में एक ही input होता है T, okay? When clock is given, T can be anything, आपका output क्या होता है सर? No change. When clock is provided, maybe edge triggering, positive edge, okay? If T is 0 or 1, what happens? If T 0, it will give you no change. T 1 है तो it will do toggle. इसको toggle flip flop कहते हैं. This is called as toggle flip flop. What is the characteristic table here? QN plus 1 and T. See here, if you want here present and next same, you should give 0. If you need present and next different, you should give 1. So what is the characteristic equation? मैंने क्या किया? 1 minute, ऐसा क्यों हो रहा है? Just a minute guys. This is the input, this is the present state. What is the next state? So present and next same, okay? If you have 0, no change. If you have 1, QN bar. So what is your QN plus 1 equation is, I'm going little fast because it is a quick revision kind of thing. So excitation table for the T flip flop, present next, what is the input? Present next same है तो 0 देना, present next different है तो 1 देना, बस simple बात है. We will use this in counter designs etc. Last case, D flip-flop, data flip-flop, whenever the input is, clock is given, input is transferred to the output. See है, ठीक है? So आपका T, D, clock, QN plus 1. Clock 0 है तो no change, clock 1 है तो नहीं है तो edge ले लो. Whatever you give, same will come. It is used for memory to save the data. इसमें क्या होता है सर? D, QN plus 1. Here, whatever you give at the input, same will come, provided clock is 1. So इसका expression क्या होता है सर? QN plus 1 equal to D. इसको transparent latch कहते हैं. Excitation table, this is characteristic table. ये हमारा ट्रूथ टेबल. फिर क्या सर? एक्साइटेशन टेबल. एक्साइटेशन टेबल तो बहुत आसान है. इट इज वेरी सिंपल. प्रेजेंट नेक्स्ट ले लो. आपको नेक्स्ट में जो चाहिए वो इनपुट में देना चाहिए. वॉट एवर यू वॉन्ट इन द नेक्स्ट सेम यू शुड गिव इट एज द इनपुट. सो Yes, quickly, this is what about your all flip flops. This is about the basics of the all flip flop. In the regular class I require at least 5 to 6 hours to complete this part by giving every single minute detail. Now how much time we have completed? Hardly 15 minutes I think. So let me quickly revise the things. So right, this is your SR flip flop truth table. 0 में 0 1 it is 0, 1 0 it is 1, set and reset, 1 1 no change, it is invalid. This is the characteristic table, characteristic equation of S plus R bar Qn. Excitation table, what is the meaning of excitation table? Present and next. Present में मेरा पास ये है, next ये चाहिए तो input में क्या क्या दे सकते हैं. Presently I am having this, next I want this, इसके लिए what are the inputs you can give? Here 0 you can give at the yes, R can be any value, it can be 0 or 1, no matter, I will get this condition. So for the JK, this is the small modification we have done so that it will give you 1 1 as a valid condition of toggling previous complement. These are the characteristic table, equation and excitation table. We will go for the master to convert the level triggered into edge trigger for JK to avoid the race condition. What is the race condition, sir? When both the inputs are 1 to avoid unnecessary number of togglings in the output for single clock, we will go for this. So tip for a toggle flip flop, when input is 1 it will toggle, otherwise it is no change. D for data flip flop, whenever clock is applied it will store the data, otherwise it will keep it in the previous state. Okay, chalo. Now let's do the conversion of the flip flop. Ideally how to do the conversion, you know, characteristic table of desired flip flop लेना चाहिए, इसके बाद excitation table of available flip flop लेना चाहिए, ऐसा लेके we should do the problem. But अभी तो मैं तो डायरेक्टली आपको फॉर्मूलाज दे सकते हैं. ऑल कन्वर्शंस क्या होता है? मेरा पास SR flip flop, how to convert SR flip flop into any other flip flop. Otherwise let me give you one table for this, it will be better. After this we start the problems. Listen, मेरा पास ये फ्लिप फ्लॉप है, क्या फ्लिप फ्लॉप? SR. ओके, मैंने इसको JK फ्लिप फ्लॉप जैसा कन्वर्ट करना चाहिए. इस केस में क्या करना? S मस्ट बी इक्वल टू JQN बार, R मस्ट बी इक्वल टू K टाइम्स QN. मेरा पास SR है, इसको JK से कन्वर्ट करने से ऐसा करना. मेरा पास D फ्लिप फ्लॉप है तो इसको JK फ्लिप फ्लॉप में कैसा कन्वर्ट करेगा सर? D मस्ट बी इक्वल टू JQN बार प्लस K बार QN. मेरा पास T है तो इसको JK फ्लिप फ्लॉप जैसा कैसा कन्वर्ट करेगा? T मस्ट बी इक्वल टू JQN बार प्लस K QN. Okay, this is how you convert T to JK. Okay, next. Similarly, you have a JK, to convert into JK, no need to convert anything. Next. Just a minute. Okay. So suppose you have SR, you want to convert into SR. इसको कोई मीनिंग नहीं, you need not. SR to suppose D to SR, क्या करना? D must be equal to S plus R bar QN. Suppose you have D, you want to convert into T flip flop, क्या करना? See, you have T, you want to convert into SR. T must be equal to SQN bar plus R times QN. How to convert JK into SR is very simple. J equal to S, K equal to R. ठीक है, हो गया सर. So how to convert? Just a minute. Right. So see here, suppose you have SR, you want to convert into JK and SR, we have discussed. Last two flip-flops क्या T. SR to T क्या करना? S equal to TQN bar, R equal to KQN. तो इसमें SR to D के लिए क्या करना? S equal to D. अरे क्या किया मैंने? One minute, sorry. मेरा पास D है, इसको T में कन्वर्ट करना, T इक्वल टू इट्स कैरेक्टरिस्टिक इक्वेशन. नेक्स्ट, मेरे पास T है, इसको क्या कर सकते हैं सर? T2 कन्वर्ट इनटू T, नो नीड. T2 JK, मेरे पास JK, इसको T का कैसे कन्वर्ट करेगा? J इक्वल टू T, K इक्वल टू T. लास्टली मेरा पास एनी फ्लिप फ्लॉप आई वांट टू कन्वर्ट इनटू D, इसमें क्या करना सर? S इक्वल टू D, R equal to D bar, S equal to T equal to D XOR with QN. Here J equal to D, K equal to D bar. Finish. This is the table which will give you total conversion of any flip-flop into any other flip-flop. This line will tell you this flip-flop into all other. This will give you this flip-flop into all other. What is the original way to do it, sir? Characteristic table of desired flip-flop followed by excitation table of available flip-flop. चलो problem शुरू करेगा. Let's start the problems. You are waiting for the problems. I know it. Let's start. Okay? Any doubt? Any other doubts? Right. Let's start the first question. आप लोग ट्राई करके आंसर बताओ. You just try the question and give me your answer. Try the question and give me your answer. I will anyway explain it, but first you try it and tell me the answer. SR to T नहीं किया क्या? SR to T तो किया ना? Okay, sorry. Thank you. Thank you guys. This is a TQN. So give your answer fastly. Master slave flip-flop has the characteristic that change in the input immediately reflected in the output. Change in the output occurs when the state of master is affected. Change in the output occurs when the state of slave affected. Both the master and slave are affected at the same time. Master will affect when clock is equal to 1. Slave will affect when clock equal to 0. But where you are accessing your output is at the slave. Who is your final output? Who is giving? Slave is giving your final output. So you can see the change in the output occurs when the state of slave is affected. Very good. Most of you have given right answer only. Next, let's do this question. The following binary values were applied to the x and y. I will do the question, okay? I don't ask every time to solve because depending on the question, I will definitely explain. When you do the problems, we will explain little more only. So see the question. The following binary values were applied to the x and y inputs of the NAND latch shown in the figure. The sequence indicated below. X, Y, 0, 1, 1, 0, 0, 1, 1. Okay. Then what is the next part? The corresponding stable outputs at P and Q are. Anybody can guess it? Can you guess it? he has given one information, NAND latch shown in the figure. Okay, nothing is specified. This model appeared 4 to 5 times in your GATE exam. This is also a previous GATE question, I think 2017 or somewhere it is given. It is appeared so many times in your GATE exam, guys. In our class also we have done a problem similar to this. So there are some questions in this class, definitely most of the questions are not discussed in our regular class. So you will see new questions mostly. So let's do it. Let's crack it. So see here. Just a minute. Right. So let's try the question. So let me copy this part. So yes, let's take the advantage of the digital board in the digital class. Okay, see here. It is a NAND latch. NAND latch. What is the truth table of the NAND latch, sir? Let's quickly revise the things. S and R, Qn plus 1. NAND वाला latch में truth table क्या होता है? It's called active low latch. Yes or no? So it is for 0 0 invalid आएगा. For 0 1 it is 1. For 1 0 it is 0. I hope you remember. This is exactly reverse. Active low कहते हैं, set reset को complementary it will work. Okay. So for NAND gate any one of the input is 0, immediately output will become 1. So for 0 0 both the outputs will become 1. That is the reason we don't take this condition as a valid condition. This is the basic of the NAND latch. It will make you quick revision. Now see here, when x equal to 0, q equal to 1, what is your, इस केस में what is your p? p क्या होता है सर? फर्स्ट वाले केस में x equal to 0, y equal to 1, p equal to 1, q equal to 0. ठीक है, इसका कॉम्प्लीमेंट ठीक है. चलो, now when you give 0 0, you will get both p equal to 1, q equal to 1, which is an invalid condition. Okay, fine, no problem. Now what we are doing is, we should analyze after p equal to 1, q equal to 1, if x equal to 1, y equal to 1, what happens? See here, generally x equal to 1, y equal to 1 में you will get a previous value only, but this is not true every time. हर केस में true नहीं होता है, क्योंकि अगर initial value invalid है तो, ये तो इनवैलिड इनिशियल वैल्यू है, तो इसमें क्या करना, आप एनालिसिस करना चाहिए. यू कैन नॉट डायरेक्टली से दैट इट विल बी इन द प्रीवियस स्टेट. इट इज ट्रू इफ इनिशियल वैल्यू वैलिड कंडीशन. अगर इनिशियल वैल्यू वैलिड हुआ तो ये तो ट्रू होता है, बट इनिशियल वैल्यू इनवैलिड है तो क्या होता है? यू शुड चेक इट. सो लेट्स चेक इट. See here. So let me analyze two cases. Firstly, assume इसका propagation delay TPD, इसका propagation delay TPD2. Okay. So now already you are having one here, one here. Okay. Assume TPD1 less than TPD2. That is, the first gate is having less propagation delay compared to the second gate. In this case, what happens? In this case, what happens? So the moment you apply 1 1 apply किया सर मैंने, सो ये वन तो यही तक पहुंचेगा, दिस वन विल कम हियर, ये वन यही तक पहुंचेगा, बोथ द वंस कम्स हियर एंड वेटिंग. नाउ व्हेनेवर यू अप्लाई 1 1, व्हिच गेट विल चेंज फर्स्ट? सर टीपीडी 1 इज हैविंग लेस डिले, टीपीडी 1 का डिले कम है, इसलिए फर्स्ट वाला गेट तो पहले चेंज हो जाएगा. 1 into 1 क्या होता है सर? 1. होल बार कितना होता है? 0. ये 0 यही तक आएगा. 0 into 1 क्या होता है सर? 0. होल बार क्या होता है सर? 1. दिस इज प्रोवाइडेड प्रोपगेशन डिले ऑफ द फर्स्ट गेट लेस देन सेकंड गेट. थोड़ा सा स्टैटिक हजार्ड्स तो हो जाएंगे बीच में. दिस इज द स्टडी स्टेट वैल्यू आई एम सेइंग. सिमिलरली एक और एग्जांपल ले सकते हैं क्या सर? पॉसिबिलिटी टीपीडी 1 ग्रेटर देन टीपीडी 2, दैट इज अभी सेकंड वाला गेट का प्रोपगेशन डिले कम है तो क्या होता है? ओके okay, now see here, first this gate will change, that is इस पे 1 आएगा, then 1 into 1, okay, 1 into 1 क्या होता है सर? 1 into 1 1, होल बार 0 होता है, ये 0 यहीं पे आएगा. 1 into 0 is 0, होल बार is 1. That is depending on the propagation delay of the individual gates, it is possible to get 0 1 or 1 0 also. Let's go back. So first case में क्या होता है सर? 1 0 1 1, PQ 1 0 ले लो, हाँ 1 0 1 1. इसके बाद क्या सर? It can be 1 0 or 0 1. ऑप्शन सी. It is another possibility भी है सर. क्या है? इफ दोनों का डिले सेम है तो क्या होता है? दोनों का डिले सेम है तो क्या होता है? इन दैट केस बोथ विल टॉगल एट द सेम टाइम, देन इट विल गिव यू 0 0 1 1 0 0 1 1. वी हैव डिस्कस्ड इन द रेगुलर क्लास. ठीक है, सो दैट इज नॉट एनीवे आस्क्ड इन दिस क्वेश्चन एनीवे, डोंट वरी अबाउट इट. सो 1 0 or 0 1. If both the delays are equal, then what happens? It will, after when you give 1 1, it will change to 0 0 1 1 0 0 1 1 ऐसा. Okay, so what is the right answer is option C. Any kind of queries, feel free to ask me, otherwise we will move to the next question. Yes Banerjee, don't worry, I will use English and Hindi together. Every single Hindi word I will give you translation, don't worry. Yes, assume करना चाहिए. Okay, if examiner has given Anjali, in that case we will definitely say 1 0, or इसलिए examiner has given, it can be any one of them. Okay, if both are having equal delay also, then what happens is if both are having equal delay, then 1 1, both will change at a time to 1 1, again both will change at a time to 0 0. Anyway, that condition is not given in the options. Thank you Patnaik. So chalo, let's move. No doubts, right? If you have doubt, feel free to ask, otherwise we will move to the next question. Yes, let's do this question. Try this question and tell me your answer. Just a minute. So there is no MSQ. बताओ, what is the right answer? Why this much delay? You can answer this question easily, guys. Neil Kumar, in that case, there can be possibility of MSQ. If examiner give the third possibility also, yes, it can be MSQ. So this question, please answer, guys. I don't need this much delay for this question. You can answer it easily. What happened? Response नहीं आ रहा है. For the circuit shown in the figure, how to do this question easily? Let's see how to do this question easily. Okay. So for the circuit shown in the figure, D has a transition. If you read this question directly, you will end up with confusion only. So I will show you the easiest way to do this question. Generally, people will try by different ways. I will give you the easiest way. So for the circuit shown in the figure, D has a transition from 0 to 1 after the clock changes from 1 to 0. इस लाइन को देख के what happens? Fear starts. By seeing the line, your fear will start. ठीक है? Assume the gate delays are negligible. Gate delays negligible करके which of the following statements is correct? If you read all these things, definitely you end up with confusion. Just wait for some time. Listen here. I will show you how to do the question easily. Okay, listen here. Please listen. Firstly, what is this? ये क्या होता है सर? ये तो नॉर लैच है ना. ध्यान से देखो. थोड़ा सा बेसिक चाहिए इसमें. वो बेसिक तो मैं देता हूँ. एग्जामिनर क्यू कहाँ दिया? नीचे दिया. एस सर नॉर लैच में एस कहाँ होता है सर? इट इज एट क्यू बार. आर कहाँ होता है? जनरली वी टेक एस इन द बॉटम, आर इन द टॉप, then q in the top and q bar in the bottom. But originally examiner यहीं पे q दिया, examiner दिया, this is given by examiner. Then if it is q, then this should be s, this should be r. This is the logic you should know before doing this question. Then SR NOR latch. SR NOR latch. Sir, SR NOR latch क्या होता है सर? S and R. ओके आपका QN प्लस 1 क्या होता है सर? जस्ट रिवाइजिंग ट्रूथ टेबल ऑफ द SR NOR लैच. इट इज 0 सॉरी QN 0 1 invalid. This is SR NOR latch truth table. Let me take this into consideration. Now see here in the question there is a small mistake. This is a inverter. This is a inverter. Okay. So please listen here. आपका फिगर जो दिया ना इसमें this is D. This is your clock. Then what is here? D plus clock whole bar. This is clock. This is D bar. Here what will you get? D bar plus clock whole bar. This will make your analysis very easy. See here. If you take S and R, in the place of S, you should connect D plus clock whole bar, and here D bar plus clock whole bar. Okay. Now, ध्यान से सुनो. What is your D and C? What is your D and C? This is your clock. It is how much? Clock is equal to 1. It is 0. Here it is 0, 0. Here it is 0, it is 1. So, 3 cases are there. D and clock में clock is 0, 1 minute. Clock and D में it is 1 0, next 0 0, next 0. Is it clear? It is 1 0, 0 0 and 0 1. Okay, fine. Now D plus C bar, D plus C bar will give you 0. Next D plus C bar, D plus C bar, D plus C bar. Next D bar plus C whole bar. D bar is 1 plus C whole bar is 0. Am I wrong? D bar plus C whole bar. इनिशियली 1 0 है ना, d0 d bar 1 plus 1 1 whole bar d plus c bar, it is 1 na, 1 minute, d plus c bar 1 d plus c bar 1 d plus c bar, ये भी 1 है, ठीक है. चलो, now here this is 0. next देखो d bar means 1 plus c 1 plus 0 1 whole bar. next, अरे क्या कुछ गलत कर रहा हूँ मैंने, c plus d bar whole bar, c plus d bar whole bar, c plus 1 d bar 1, c plus d bar whole bar. I'm just something wrong, c plus d bar 0 plus 0 whole bar is, just a minute guys, I have committed some mistake somewhere. In the figure this is d and clock, d plus c whole bar, correct. Here it is clock d bar, clock plus d bar whole bar, correct. So initially clock is 1 and d is 0, next 0 0 0 1, correct. c bar is 0, अरे एक मिनट, c bar is 0 plus d, why I did this. next c bar, okay, d plus c bar, d plus c bar 0 plus 1, d plus c bar, d plus anything is 1, okay. Here d bar plus c, d bar means 0 bar, 1 plus 1 whole bar is, again I am writing wrong, 1 d bar plus c whole bar, d bar plus c is 1 plus 1 whole bar is 0, d bar plus c, d bar plus c 0, next d bar plus c, ऐसा आ रहा है. Am I committed some mistake in the calculation? Wrong expression in the table, just check, let me check. Which one, please comment. Gagan, expression wrong likha. Okay, okay, it is d plus c whole bar. I am sorry. So d plus c whole bar, this plus this whole bar, 1 plus 0 is 1, whole bar is 0, 0 plus 0 0 whole bar is 1, okay. 0 plus 1 1 whole bar is 0. next, is it okay now? d plus c, 1 plus 0 is 1, whole bar is 0, 0 whole bar, 1 whole bar is 0, correct. Okay, in the R also what I have committed, d bar plus c whole bar, this is fine, this is d bar, this is c, this plus this whole bar, so d bar plus c, 1 plus, you take 1 plus 1 whole bar is 0. In R any mistake is there? R पे कुछ mistake है क्या, ऐसा क्यों हो रहा है आज? C और d bar, c plus d bar whole 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 bar. So in this case you can take no change, 1 0. So let's go back. What is the question? Q goes to 1. See, when it goes to 1, before d becomes 1. इस case में your Q equal to 1 and again here it will become 0. Okay. So please listen, understand this. Q goes to 1 before d becomes 1. When d becomes 1, Q becomes 0. So please go back, see here, Q goes to 1 at the clock transition, okay. Whenever clock becomes 0, during that period d is equal to 1, correct, and goes to 0 when d goes to 1. I am repeating, please go back, see here. whenever clock becomes 0 during 0 0 condition, that is input is not 0 0, clock and D are 0 0, during that period Q goes to 1, and again when D becomes 1, it becomes 0. Okay, this is the simplest question. If you write the equation, there is no confusion. आप मैंने confuse किया, but you need not confuse. Whole bar I have not taken, that is the problem. Okay, चलो next question. Read this question, try to answer it. Give a try and tell your answer. 1 minute, Patnaik, what is your doubt? Just let's clear Patnaik doubt. What is that? See here, simple thing. Here, whenever clock transition means clock changing from 1 to 0 or 0 to 1, उस समय पे these two becomes 0 na. At that time, what is the output you got? 1. So at the clock transition you got 1. Whenever D becomes 1, again it has become 0. That is given in the option. During when Q goes to 1 at the clock transition, meaning is when clock changes its position and goes to 0 when D goes to 1. So try this question, guys. I will give you some time, just give a try. Gagan, you see here examiner has given, I have not taken. These are the inputs 1 0 0 0 0 1 is given by examiner only. This figure is given by examiner. Yes or no? It is 1 0 0 0 1 1 condition. Is it fine? Gagan, those things are given by examiner. This is 1 0 0 0 0 1. Based on that, I write the expression. It is clock plus D whole bar. This is D bar plus clock whole bar. Okay. So whatever examiner given, I took the same things. These are given by examiners. Then based on that, I write the expression. So try this question, guys. It is also good logical question. You people can try it. Very good. Try the question and try to give your answer. Yes. So when when the output Y of the circuit below is 1, it implies that output data has. Suppose if this output Y is 1, what does it indicate? The data has changed from where to where? 0 to 1, 1 to 0, in either direction, not changed. Let's do this question. Okay, very good, very good, very good. So see here. Here your output is a Q. Okay, you just give the namings. Okay, this is Q1 and Q0. So what is your output? Q0 into Q1. Okay, listen. When the output of the circuit below is 1, what does it mean? See here. Here, to get 1 here, what is the required condition? You should have 1 here and here also. That is, these two should be present at the input of the system and clock is applied. Please listen here. These two should be present at the input of these systems and clock is applied. That is, you need here 1 and here 1. ये तो possibility नहीं, sorry, इसका input में क्या? Here 1 and clock is applied. So initially this is the input condition you should have. So initially I should have here 0. I should have 0. Now see here, suppose this is the circuit condition. If you apply clock, what happens? This one will come here, this one will come here, then both will be 1 and my output is equal to 1. So what is the required condition is, this should change, initially 0 should become 1. If it is 0 here, this will be already 1 waiting. Once you make this 1, this will become 1 0. By the time this 1 already comes here. So please listen, you may have the doubt, sir, if this becomes 1, this will become 0 now. Yes, it will become 0, but it will not reflect in the output, it will reflect in the next clock. So what is the required condition is, my input should change from 0 to 1. Most of you have given right answer. Very good. Very good. चलो नेक्स्ट क्वेश्चन. सो ये वाला क्वेश्चन ट्राई करो आप लोग, आंसर बताओ. गिव ए ट्राई एंड टेल योर आंसर. I will wait. Okay, let me explain this. I will give you the explanation. Listen here. The state transition diagram of a logic circuit is shown below. This is the state transition diagram of the flip-flop given. So using this, you need to find what is the state diagram. Okay, so let's see here. For example, here what is the input? A. What is your output expression? Y is equal to A bar into X naught plus A into X1. So when A is equal to 0, your output Y is equal to, when A is equal to 0, what is your output Y? When A equal to 0, output Y is Q bar. When A is equal to 1, what is your output Y? Q. So abhi listen here carefully. When A equal to 0, it should do complement. When A equal to 1, it should do Q as the output. So see the figure, whichever it is doing. See here, when A is 0, it is doing the transition. When A equal to 1, it is in the same state. So A equal to 0, it is doing the transition. When A equal to 1, it is in the same state. So what is the right answer is option D. Very good. Last option, correct. Chalo, next question. So try this question. Right. So what is the right answer here? I am just giving you intentionally time so that you will also give a try. That is the intention. So let me try. So choose the correct statements relating to the circuit shown in the figure. So this is a op-amp comparator circuit. For example, let's start with the first case. If Vi is equal to -2, P equal to 0. Okay, so let me apply first option. Option A, if Vi is equal to -2. Comparator में positive is negative compared to this, you get 0. Okay, this is your SR latch, this is S and R. Q bar lena. Okay, so here -1 is there. Positive is more, sorry, negative is more negative than positive. Then you get S equal to 1, R equal to 0. When S equal to 1, R equal to 0, what do you get? P equal to 1. So first option is wrong. Is it clear? Comparator circuit में positive should be more positive compared to negative, then you get 1, otherwise you get 0. In NOR gate, NOR latch, bottom is S, top is R, you know it. If you take this as Q. Okay, next case, second case analyze करेगा. When Vi is equal to plus 3, when Vi is equal to plus 3, what happens? When Vi is equal to plus 3, here 3 is there, so positive greater than negative you get 1, negative is greater than positive you get 0, so for 0, 1 your Q will be equal to 0. Yes, this is right answer. Okay, you can check the remaining two options also, nothing wrong. So this is the option B is the right answer. Very good. Let's move. This is the simple question, you can try. Which one will give you right option among them? Let's try it. What's the time, guys? How much time is up? We started at 9, I think. What's the time? Wow, already more than 1 hour is up. So it's time for flip-flops to stop, right? We should move to registers. We'll move it. So see the circuit shown in the figure. Choose the correct timing diagram of the given waveforms. Which one will be correct among the Y? For Y, what is the right answer? You have what is that? D flip-flop. Negative edge triggered. So negative edge trigger ले लो. This is a negative edge triggered D flip-flop. Okay. So what is the output is equal to? Very simple question. X1 into X2. At the negative edge, it should give you X1 into X2. So at the negative edge, what is X1 into X2? It is 0 into 0. It should give 0. All are passed. Next. It should wait in the up to the next negative edge. At next negative edge tak it should wait. But here it changed before itself. Wrong. Here also it changed before because it is negative edge triggering. Na? Output should change at the negative edge, but here it changed at positive edge. These two are eliminated. So your answer must be either W1 or W3. So at the negative edge, see here. Again 1 into 0. What is the answer, sir? 0, but this is 1. So this is also wrong. So in fact all are looking 1 into 0 is 0. Correct. Next negative edge, it is 1 into 0, 0. Next negative edge, both are 1s. Yes, it should give 1. Where is that? After some delay, it has given 1. So we can assume this is correct. Okay. Originally, here it should give 1. Okay, but some delay is there, but it has given 1. Because it is a negative edge triggering. Okay. चलो ये वाला क्वेश्चन तो किया ना. Now this is done already. What is this circuit? What is the importance of this circuit? The circuit shown in the figure will act as a what? It is working like a master slave D flip flop. It can be used to convert level triggered flip flop into edge triggered flip flop. We have discussed this in the regular class already. Right. Let me give you one question. Where is my question? Yeah. Implement the following flip flop whose state table is given below using D flip flop. Please try this question. This is an innovative question. You can try. right? This is the truth state diagram given by examiner. Whoever tries this question, you need to find what is the input D. D को क्या input देना इस वाला flip flop implement करने के लिए. To implement this वाला flip flop, what is the input you should give it to D? This is my own question. You can try this question, guys. Yes, try the question. It's a simple question if you crack the logic of the question. Question का logic crack किया तो बहुत easy है. What is the input you should apply to the D flip flop D to make this? Yes, we need to find a D input. आपने A flip flop implement करना. You need to implement this flip flop using D flip flop. To do that, what is the input you should give to the D? Okay. अरे क्या इनपुट ये इनपुट 0. Very good, Kailash and Mamata Agarwal. Ready, very good. This is nothing but, yes, excellent. It is the state table of JK flip flop. Yes or no? It is when it is in 0, if you give 0 across, it will stay at 0. If you give 1 cross, it will go to 1. If you give 1 से 0 के आने के लिए cross 1 देना चाहिए. If it is at 1, to stay it at 1, you should give cross 0. That is, you should make a JK flip flop using D flip flop. What is the condition I told already? That is AQN bar. That's all. This is a simple question. Okay. Is it clear? Is it fine? So let's take one more question. Implement, then we will move to registers. AB flip flop using JK. Okay. Next question, this one. So see here, I want this condition, I want this flip flop, okay, using JK flip flop. आप लोग try करके what are the inputs to be given for J and K, you should tell me. What are the inputs to be given to J and K? You try this question. This is also a famous model in the GATE. So after this we will end the flip-flop part, then we will move to the register questions. Okay. Give a try and tell me the answer. If you are my student, you don't need much time. आप मेरा स्टूडेंट है तो ज़्यादा टाइम नहीं लगेगा, 1 मिनट में इसका प्रॉब्लम का सोल्यूशन मिलेगा आपको. मैंने बहुत सारे टेक्निक्स दिया रेगुलर वाला क्लास में. हाउ टू कन्वर्ट वन फ्लिप फ्लॉप इनटू अनदर फ्लिप फ्लॉप. दोनों कैरेक्टरिस्टिक इक्वेशन इक्वेट करके कर सकते, नहीं है तो क्या एक और मेथड भी दिया, ट्राई करो उस वाला मेथड पे. क्या इतना टाइम क्यों हो रहा है? देखो मैंने शॉर्टकट देता हूं. हाउ टू डू इट कन्वेंशनली. You should write characteristic table of desired followed by excitation table of available. ये ओरिजिनल प्रोसेस है. कैरेक्टरिस्टिक टेबल ऑफ डिजायर्ड फॉलोड बाय एक्साइटेशन टेबल ऑफ अवेलेबल. ऐसा करना चाहिए तो आप लोग ऐसा घर पे करो. अभी सर डोंट से आई एम ऑलरेडी एट होम. ठीक है, आई मीन क्लास के बाद करो. ठीक है, चलो अभी देखो ये भी फ्लिप फ्लॉप. हमारा पास क्या फ्लिप फ्लॉप है सर? जेके. शॉर्टकट दे रहा हूं, ध्यान से देखो. इस पे जे ले लो, के ले लो. क्यू एन बार आने के लिए क्या करना सर? क्यू एन बार आने के लिए क्या करना? 1 1 देना चाहिए. 1 आने के लिए क्या करना सर? 1 0 देना चाहिए. 0 आने के लिए क्या करना सर? 0 1 देना चाहिए. क्यू एन के लिए क्या करना सर? 0 0 देना चाहिए. बस हो गया प्रॉब्लम. मेरा इनपुट में ये आए तो मैं आउटपुट में ऐसा कन्वर्ट किया तो जेके फ्लिप फ्लॉप ऐसा काम करेगा. इफ माई इनपुट इज दिस, इफ आई कन्वर्ट दिस इनटू दिस, माई जेके फ्लिप फ्लॉप विल वर्क एज पर माई रिक्वायरमेंट. So now see here. Qn bar. How to get Qn? See here. What is J? J is 1 for 2 conditions. What are they? A bar, B bar plus A bar B. You can say it is expression is A bar. K is 1 for 2 conditions. What is the expression for K, sir? A bar, B bar plus A B bar. It should be B should be 0 in both the cases. You can say what is the answer for the expression is B bar. When you make J equal to A bar, K equal to B bar, this will work like a AB flip flop. JK flip flop will work like a AB flip flop as per your requirement. So this is one method. There is another way to solve this question that I have given shortcut as the regular class. This now also I will give you that. Let's do it. Is it fine? Just compare with the truth table, you can make the things. This is the shortcut. Whenever you need to convert using JK, you can use it. Another method I am giving you is characteristic equation method. This also I have given in my regular class. Equate the characteristic equation of both the flip-flops. That is also another way to solve these kind of questions. What is that? Qn plus 1 of both the flip-flops with available on the left hand side, that is JK. Here you take this equation. ओके इसका इक्वेशन क्या होता है सर? ए बार बी बार क्यू एन बार प्लस a bar b into 1. You can neglect 0 because a b bar into 0, then a b into qn. So here you can write this one as qn bar plus qn. Then you can take qn bar common, a bar b bar plus a bar b. Then qn common, a bar b plus ab. हो गया problem. Here you can take a bar common. This is a bar qn bar after simplification plus here you can take b common. This is b times qn. Just compare the coefficients of jk flip flop. आपका qn bar का coefficient j है ना, so j क्या होना चाहिए? a bar. K bar should be equal to B or K must be equal to B bar. Same answer. This is my own method, that is equating the characteristic equation of both the flip-flops. This is applicable any condition except SR because its characteristic equation is not valid for 1-1 condition. Very good, very good, very good. So let's move guys, next question. Is this fine? If you have any query, feel free to ask me at any point of time. You can ask me. My intention is every single student is able to learn. सारे students का clear doubts class में clear होना चाहिए, पर every single student doubts must be cleared in the class itself. Okay, let's go to the next. Okay, that will end the discussion on the flip-flops. Now we will move to the registers. Okay. Okay, so please listen. So let's start with the registers. Registers क्या होता है sir? Registers are the group of flip-flops cascaded together to store the data. Registers क्या क्या करेगा sir? These are the group of flip-flops cascaded together to store the data. Registers का काम क्या है? It is just to store the data. It can also do shift operation, left shift or right shift. It can be used for arithmetic operations. So based on the input-output configuration, registers को कैसा classify कर सकते हैं? 4 बार में classify कर सकते हैं. क्या sir? Serial input, serial output, serial input, parallel output, parallel input, serial output, and parallel input, parallel output. ये क्या होता है सर? लेट मी गिव यू दैट. Let me take one example. Quick revision. See here, सिसो में, सिसो का मतलब सीरियल इनपुट सीरियल आउटपुट. ये तो क्लॉक, सारे फ्लिप फ्लॉप का क्लॉक कॉमन लेना चाहिए. ठीक है। So here we apply the input, here we take the output. इसको क्या कहते हैं सर? सीसो सीरियल इनपुट सीरियल आउटपुट। इनपुट बिट बाय बिट इस पे अप्लाई करेगा, आउटपुट बिट बाय बिट लेता हूँ। सो इसमें जनरली इनपुट के लिए n क्लॉक पल्सेस चाहिए टू लोड द इनपुट, आउटपुट के लिए n-1 क्लॉक पल्स चाहिए। एंड ऑल्सो मैंने जो एग्जाम्पल दिया ये तो राइट शिफ्ट कर रहा है, यू कैन गिव इनपुट हियर एंड टेक द आउटपुट हियर, ये तो लेफ्ट शिफ्ट होता है। ठीक है सर। सो इनपुट सीरियली दे दो, बट आउटपुट क्या करना सर? पैरेलली ले लो। इस केस में क्या कहते हैं सर? सिपो, सीरियल इनपुट पैरेलल आउटपुट। इस केस में इनपुट क्या होता है सर? इस केस में इनपुट अप्लाई करने के लिए n क्लॉक पल्स चाहिए, मुझको आउटपुट में कुछ नहीं चाहिए। ये तो सीरियल टू पैरेलल कन्वर्शन और टेम्पोरल टू स्पेशियल कन्वर्शन करेगा। व्हाट इट विल डू इज सीरियल टू पैरेलल और टेम्पोरल टू स्पेशियल कन्वर्शन। सो सिमिलरली इफ यू गिव इनपुट पैरेलली and the take output serially, इसको क्या कहते हैं सर? पिसो, पैरेलल इनपुट सीरियल आउटपुट। ओके, इन दिस केस आपका इनपुट के लिए एक क्लॉक चाहिए, आउटपुट के लिए कुछ नहीं, नहीं, आउटपुट बिट बाय बिट ले रहा हूं, n-1। लास्ट वाला क्या सर? इनपुट भी पैरेलल, आउटपुट भी पैरेलल। ये तो शिफ्ट नहीं स्टोरेज रजिस्टर होता है। इसमें क्या सर? इनपुट के लिए दिस विल कन्वर्ट पैरेलल टू सीरियल और टेम्पोरल टू स्पेशियल। इनपुट के लिए 1 क्लॉक, आउटपुट के लिए no क्लॉक। So this is the storage example and shift examples. That is the basics of the serial input and parallel output. It is nothing but a cascade connection of the flip flop. Clock common to all flip flops. Don't think clock is applied to one flip flop. Clock सारे flip flops का common है। एक flip flop का output दूसरे flip flop के input में connect करेगा। चलो, so ring counter क्या होता है सर? Let's check, हमारे पास फिगर है तो लेता हूँ, नहीं है तो नो प्रॉब्लम। रिंग काउंटर क्या होता है? लिसन, you can represent in the better way like this. For example, ठीक है, ये आपका क्लॉक, so flip flop D3, D2, D1, D0. ओके, एक का आउटपुट दूसरा को दिया। ओके, वन आउटपुट इज गिवन एज द इनपुट टू द अनदर। सो लास्ट वाला आउटपुट लेके फर्स्ट वाला को कनेक्ट किया, तो इसको क्या कहते हैं सर? रिंग काउंटर। ठीक है, लास्ट वाला आउटपुट कॉम्प्लीमेंट करके दिया तो इसको क्या कहते हैं सर? जॉनसन काउंटर। ओके, दिस इज द जॉनसन। सो इसमें रिंग काउंटर में कितना स्टेट्स होता है सर? आउटपुट में n t स्टेट्स और n स्टेट्स। ओके, एंड 2 power n-n unused states. Okay, this is n bit. Okay, here output frequency equal to f clock by n, and here duty cycle of the output 100 by n%. Relative phase shift between one signal to another signal is relative phase shift. कितना होता है सर? 360 degrees by n. It will generate the signals of same frequency with a relative phase shift of 360 degrees by n. Like 3 phase, 4 phase, whatever you require, it can generate it. Ring counter. इसमें क्या होता है सर? 2n states आएगा, 2 power n minus 2n unused. Okay, and output frequency is equal to f clock by 2n. और फेज शिफ्ट कितना होता है? रिलेटिव फेज शिफ्ट 360 डिग्रीज बाई 2n. बट हियर ड्यूटी साइकिल क्या होता है सर? इसमें 50%. ओके, से फॉर एग्जांपल हियर यू टेक 3 बिट्स, इट विल बी 0 0 0 0 सॉरी 1 0 0 0 1 0 0 0 1. ऐसा काम करेगा. फिर अगेन 1 0 0 and so on. If you take here 3 bits 0 0 0 1 0 0, इन्वर्ट हो क्या आएगा? This is, it is also called unit distance code generator. क्योंकि here we take one inverter and connect it. Okay, so here we connect it directly in the loop. First bit we apply 1 on its own. Okay, we will apply 1 at the starting, then it will on its own, it will rotate. This is about your ring and Johnson counters. Okay, let's start some questions. Do the problems. Try करो भाई, ये वाला question try करके answer बताओ. 1-2 questions from our regular class also, so that new students are also able to learn. And few questions are new, completely new questions are also there. Okay, so all these questions from the registers we will do it now. So let's do one by one. So try the first question. Yes, Manoj, if you have already completed all videos, then definitely you will be able to do it in the remaining 2 months. मैंने एक वीडियो बनाया, please go through that in my profile, last 2 months strategy वाला. You can go through that. I have given you the link. Okay, it's not passed. I am waiting for your answers. Okay, shall I do it or you people try it? Shall I start doing it or will you give a try? Will you give a try, guys? Tell me. Okay. See, listen here. This is the circuit given by the examiner. Let's read it one by one. The circuit shown in the figure is a parallel input, parallel output. Shift register is there, which loads at the positive edge. ये तो positive edge triggered है, ठीक है. So and the input lines are connected to the 4-bit bus, and see here W, okay, its output acts as input to the 16/4 ROM. ROM का एड्रेस में ये कनेक्ट हो जाएगा एंड ये डाटा पे कनेक्ट हो जाएगा, ठीक है. सो एड्रेस एंड डाटा कंटेंट्स आर ऑलरेडी गिवन बाय एग्जामिनर. सो इस वाला केस में 2T1 और T2 दो इनपुट्स है. सो यही पे ऑलरेडी लाइन पे कितना दिया एग्जामिनर एट T1 इफ यू हैव 0 1 1 0, T2 में कितना होता है. सो लेट्स डू. T1 में इनिशियली कितना है सर 0 1 1 0, ओके. 0 1 1 0 का मतलब 6. सो फर्स्ट क्लॉक आपने अप्लाई किया तो T1 टू T2 के बीच में दो पॉजिटिव एजेस आया. फर्स्ट क्लॉक पल्स अप्लाई किया तो क्या होता है सर, फर्स्ट वाला क्लॉक पल्स में चे यहीं पे यहीं तक आएगा. फर्स्ट क्लॉक पल्स अप्लाई करने के बाद 0 1 1 0 यहीं पे आएगा, बिकॉज इट इज ए पिपो, पैरेलल इनपुट पैरेलल आउटपुट. इनपुट में जो दिया आउटपुट में वो आएगा. अभी देखो मैंने एनेबल तो 1 है रॉम का. सो ये आपका एड्रेस, इस वाला एड्रेस में 0 1 1 0 है तो आपका आउटपुट में डाटा आएगा. डाटा कितना 1 0 1 0, डाटा कितना 1 0 1 0, दैट इज द एड्रेस एंड डाटा. सो द डाटा, इट इज a combinational circuit, no need of any clock. So the new data is 1 0 1 0. So 1 0 1 0 यही तक पहुंचेगा. 1 0 1 0 will come up to this location. But क्या हुआ, clock is not yet applied. It should wait for the second clock. Second clock apply किया तो when I apply the second clock, what happens? This 1 0 1 0 will come in the output. सेकेंड क्लॉक अप्लाई करने के बाद वो 1 0 1 0 इनपुट में है ना, वो आउटपुट में आएगा. बिकॉज पिपो क्या करेगा, इनपुट में जो है वो आउटपुट में आएगा. पिपो विल कन्वर्ट वॉट एवर प्रेजेंट इन द इनपुट एज इट इज, इट विल कमिट इन द आउटपुट. सो नाउ सी हियर 1 0 1 0 1 0 1 0 का मतलब क्या सर, 1 0 1 0 का मतलब क्या, इट इज एड्रेस. अभी 1 0 1 0 का मतलब 10, 1 0 1 0 मीन्स 10. एट दैट एड्रेस व्हाट इज द डाटा प्रेजेंट 1 0 0. So 1 0 0 will come here. Okay. So now the new data is 1 0 0 after the second clock pulse. Examiner has asked up to this location only. So what is the answer? By the end of time T2, you will be having, what is that? 1 0 0 as the answer. By the time T2, you will be getting 1 0 0 as the answer. Any queries? So you can see there are two links of my special classes, one for those who start the preparation right now, starting from now in 2 months how to crack the exam. There is another one in the what we call another one is to how to utilize the last 2 months time for your preparation. दोनों links दिया, special classes, free classes, you can go through it. What is your doubt, RKS? If you have doubt, please clearly ask it, I can definitely explain. Okay. Right. चलो next वाला question पे. Right. Give a try and tell me the question. For the circuit shown in the figure, the counter state initially 1 0 follows the sequence. What is the sequence you will get at the output? You can try this question. RKS, if you are lazy in commenting your question itself, don't expect the answer. Comment. I hope you know how to type. You have studied something. Okay, just type your doubt clearly. I can definitely explain you. Sir, explain. Sir, 2K. इसमें क्या बताऊंगा? Okay. So don't give your shortcuts. ये तो WhatsApp का चार्ट नहीं भाई. ये तो you are asking the doubt. Ask it in a proper format. If you don't know how to communicate also, how can you succeed in your life? फिर again same, second set, second clock. ये क्या है? Ask doubt in a proper format. See here. First clock pulse में क्या हुआ? 1 0 1 1 0 यहीं पे आया. Second, then 0 1 1 0 में 6 ना, 6 में 1 0 1 0 is present. ROM will give you 1 0 1 0. ROM will give you 1 0 1 0. That 1 0 1 0 will come here. Whenever you apply the second clock, this 1 0 1 0 comes here. 1010 का मीनिंग क्या सर? 10. At the 10 location, what is the data? 8. So 10th location में 8 is there, that 8 will come. Simple. Is it fine now, RKS? Okay, let's move. Try, give your answer guys. You people can try the question and give your answer. आप लोग ट्राई करके इसका आंसर बताओ. Give a try. Dhruv Gupta, if you design any sequential circuit, excitation table is very important. If you see the counters class of my crash course, you can understand how to design a synchronous counter, how to design a finite state machine. In all the cases, when the design of the any synchronous circuit, excitation is table is compulsory. So when you are designing any system, you will be having present state. Next what you need. So इसके लिए हम input में क्या देना? What are the inputs you need to give for doing that? That is given by excitation table only. So people are giving different answers. Let me try my way of doing the question. दोनों D flip flops है तो don't take much time because both are D flip flops. ये तो आपका D1 है. इसका आउटपुट D0 में कनेक्ट किया, नहीं तो D0 का आउटपुट D1 पे कनेक्ट किया. इसका आउटपुट एंड इसका आउटपुट दोनों लेके नॉर गेट को कनेक्ट किया. ठीक है, चलो अभी क्या करना. सो इनिशियली 0 0 पे शुरू किया. सो 0 + 0 क्या होता है सर? 0 + 0 0 होल बार 1 वापस आएगा, ये 0 शिफ्ट हो जाएगा. 0 + 1 1 होल बार कितना? 0 और 1. 0 + 1 1 होल बार 0 और 0. These are the states it is going through. 1 0 0 1 0 0. So 1 0 0 1. एग्जामिनर को सीक्वेंस Q1 Q0 का चाहिए ना. सो 0 1 1 0 0 0 0 1 1 0 0 0. Okay, simple question. You add these two, complement and give it here. Add these two, complement and give it here. Add these two, complement and give it here. It is valid for only D flip flops because for D flip flop whatever you give in the input same will come in the output. Otherwise we should analyze in the counters design. I will explain that. Okay, very good. Next question. Yes, try this question. You can try this question. Okay, so it's also a same model question, right? You have a 3 D flip flops connected in the loop and these two are connected with a exclusive OR gate. Let me do this question again. Same way, whatever you have tried, आप लोग try किया ना, similar method पे आप लोग कर सकते. So let's give a try. So हमारा पास QA, इसका आउटपुट में QB, इसका आउटपुट में QC. फाइनली व्हाट हैपेंस? QC और QB दोनों लेके एक XOR गेट को कनेक्ट किया. सो दोनों एक XOR गेट को कनेक्ट किया तो क्या होता है सर? सो इनिशियली सारे 0 से शुरू करो. ओके, सो 0 + 0 होल बार क्या होता है सर? 0 + 0 होल बार XOR. 0 + 0 XOR. कुछ गलत किया क्या? XNOR ले लो. नहीं है तो आगे नहीं चलेगा. XNOR ले लो. 0 + 0 क्या होता है सर? 0 होल बार 0 XNOR विथ 0 1, दोनों सेम है तो 1 आएगा. If both are same you get 1, both are different you get 0, both are same you get 1, both are different you get 0, and these two are shifted. Both are different you get 0 and these two are shifted. Both are different you get 0 and these two are shifted. So this is the sequence it is going through. Both are same you get 1, both are same you get 1, these two shifted. Both are different you get 0, these two shifted. Both are same 1, different 0, different 0, different 0. So ऐसा हो रहा है. So एग्जामिनर को क्या चाहिए? QA का मतलब ये ले लो. So QA क्या होता है सर? 0110 1000. Okay, simple question. This is how you can analyze. Let me take some water. Yes, it is doing the shift right now. So is it fine? Shall we move further? See here, simple Anjali. Whatever present here, when you apply clock, because it is D flip-flop, this will come here. All shift registers are made with D only. If you use it with JK also, you can convert into D and do it. So whatever you have here, that will come here. Whatever you have here, that will come here. So these bits will be shifted, and this not directly with the help of XNOR it is shifting. Okay. Next. This is a 2016 GATE question. Try the question, guys. Give a try. So unknowingly your 2 hours are completed. So last 1 hour to complete the class. Then we will move to 2 topics are completed. We are running on time. Registers, flip-flops completed. Then we will move to counters or the synchronous design part. Okay, give a try for this question. So read the question, guys. Assume that all the digital gates in the circuit shown in the figure are ideal. The resistor is having a 10 kilo ohms. The supply voltage is 5 volts. The D flip-flops D1, D2, D3, D4, D5 are initialized with the value of 0, 1, 0, 1, 0 the respectively. The clock has a 30% duty cycle. So the average power dissipated in millivolts across the resistor R is, see here, 0, initially 0, 1, 0, 1, 0. Yes or no? Okay. So please see D1, D2, D3, D4, D5. Okay, D5 is connected back here. So clock 0, it is 0, 1, 0, 1, 0. Okay, right? So the first clock. So now what happens? Every clock it will rotate. This 0 comes, remaining 4 shifted. This 1 comes, remaining 4 bits shifted. This 0 comes, remaining shifted. This 1 comes, remaining shifted. This 0 comes and remaining shifted. Now, if what is the OR gate is having Q5 and Q3. So Q5 और Q3 क्या होता है सर? 0 plus 0, 1 plus 1, 0 plus 0, 0 plus 1, 1 plus 0, 0 plus 0. Okay. So here, out of the 5 clocks, because after 5 clocks it is repeating the same again, that's why I took only 5. 5 clock pulse के बाद ये तो sequence repeat हो रहा है, so इसलिए हम 5 ले लिया. So अभी देखो 5 टाइम पीरियड कितना है सर? 5 क्लॉक पल्स. ये वाला आउटपुट वेवफॉर्म देखो, प्लीज लुक एट द आउटपुट वेवफॉर्म. 5 क्लॉक पल्स में कितना क्लॉक पल्स ऑन है, कितना क्लॉक पल्स ऑफ है? हाउ मेनी क्लॉक पल्स इट इज ऑन एंड हाउ मेनी क्लॉक पल्स इट इज ऑफ? इट इज ऑन फॉर 3 clocks and off for 2 clocks. So why you are doing all these things? Because examiner को average power चाहिए. Let's go to the network basics. P average क्या होता है सर? VRMS whole square by R. VRMS whole square by R. So VRMS क्या होता है सर? Root of mean. This output voltage is whole square क्या होता है? 1 by T naught integral 0 to T naught x square or V square of T dt. If you take root, whole square cancels. That is the VRMS, root mean square value. So आपको 5 टाइम पीरियड इज 5t. कितना टाइम ऑन है सर? 3t. Because it is area, you can shift the pulses, area will not disturb. So voltage कितना आ रहा है सर? 5 square. And 2t, it is giving you 0. इसका एरिया निकालो, आपको क्या? 25 by 5t into 3t. It is 15. ठीक है. आपका पावर कितना होता है सर? 15 by 10 के 1.5 मिली वोल्ट. कुछ डाउट्स है तो बताओ, इसमें कुछ डाउट है तो बताओ. वेरी गुड. एनी काइंड ऑफ क्वेरी यू कैन आस्क. Any queries? No. Let's move. Let's move to the next question. In fact, maybe last question in the so the question is, in the Johnson counter, if initial value is equal to 010, comma, if input clock is equal to 18 kilohertz frequency, okay, then what is the output clock frequency? You try this question, tell me the answer. Try the question and give me your answer. 8 है सो एक भी राइट आंसर नहीं आया क्या? 1.5 आया, 3K आया, 3K आया, 6K आया। अरे भाई आंसर तो 9 किलो हेज है, आंसर इज 9 किलो हेज, इट इज नॉट 8K 6K। ओके, सो जनरल आंसर क्या होता है सर? मोस्ट ऑफ द पीपल 18K बाई 2 इंटू 3, ये तो 3K आएगा, रॉन्ग आंसर। ओके, 18/6, ओके, बिकॉज इट इज ए जॉनसन काउंटर, यू विल थिंक लाइक दैट, नो, रॉन्ग। इसका इनिशियल वैल्यू दिया ना एग्जामिनर, इसको यूज करो। आप इनिशियल वैल्यू चेक करो, 0 1 0, Q2 Q1 Q0, इसमें एक इन्वर्टर लगाया, ठीक है। सो क्लॉक 1 पे क्या होता है सर? 0 बार चलेगा। क्लॉक 2 पे क्या होता है सर? 1 बार चलेगा। क्लॉक 3 पे फिर 0 बार चलेगा 1, ये दोनों शिफ्ट। क्लॉक 4 पे 1 बार चलेगा, शिफ्ट। इसका मतलब अगर इनिशियल वैल्यू सारे जीरोस में स्टार्ट किया तो इट विल गो थ्रू 2n क्लॉक पल्सेस, बट इसमें इनिशियल वैल्यू कहां पे शुरू किया सर? 0 1 0 पे। If it starts from 0 0 0, it will go through the 2n states, but here it starts from 0 1 0, but it is not going through 2n states, it is going through only 2 states. Here is a trap. So 2 states है तो आपका f0 क्या होता है सर? f clock by 2, that is 18K by 2, 9 kilohertz. That's all. Yes, 9 is the right answer. Okay, so shall we move further? Let's go to the next question. You can see the sequence. After 2 clocks, it is repeating the same sequence. It starts with 0 1 0, after that it is repeating after every 2 clocks. Right? शिव कुमार रेड्डी, जस्ट गो थ्रू 1040 में मैंने एक कमेंट दिया, हाउ टू क्वालिफाई इन द गेट। जस्ट गो थ्रू दैट वीडियो, यू विल गेट द क्लैरिटी। प्री लेक्चर इज देयर, हाउ टू क्वालिफाई इन द गेट। यस पटनायक, चलो। सो प्रीवियस क्वेश्चंस तो रिपीट नहीं होता है, पैटर्न्स माइट रिपीट, बट यू नीड कॉन्सेप्ट। जस्ट अंडरस्टैंडिंग द प्रीवियस प्रॉब्लम डजंट मेक एनीथिंग, इसका बिहाइंड कॉन्सेप्ट इफ यू नो सफिशिएंट। For getting 30 marks, these 2 months are highly enough. You can, if you start now itself, if you work properly, you can get up to 50 marks in these 2 months, no doubt in it. So for that, I made a special class video. Everybody can go through my profile. So how to, how to qualify GATE in 2 months for beginners. I have made the video. It is available in the comments also. At 10:40 in the comments it is there. You can go through that. Okay. Let's go through the next question. So here see, it is a pseudo random generator. What is that pseudo random, sir? In my class, regular class, I told you it is called semi random sequence generator. Your shift registers, linear feedback shift registers with a feedback loop connected like this with some XOR gate or something, it will work like a semi random sequence. It will generate some kind of semi random sequence. Okay. So what is the question given by? Initially 111 है तो after 3 clocks what is the output? Please give a try. You can do it, this question. Yes, Thakur, it is f clock by 2n if it goes through 2n number of different states. But in the previous question it is going through only 2 states. After 2 it is repeating. See the output waveform. Don't blindly take f clock by 2n every time. This is wrong. ये तो गलत है. If it starts from all zeros, it will go by f clock by 2n. So let's do this question. Counters तो wait कर रहे हैं हमारा पास. सो 3 बिट सूडो, इतना टाइम नहीं लगाना चाहिए, बताओ, ट्राई करके बताओ, जस्ट 1 minute आई कैन गिव यू द टाइम, यू कैन डू इट, गिव ए ट्राई. So सिंह दिया ऑप्शन डी, लेट मी चेक. सो इनिशियली हमने 3 1 से शुरू किया. वी स्टार्टेड विद 3 1s फॉर Q2, Q1, Q0, and Q1, Q0 are connected with one exclusive OR gate. Q1, Q0 are connected with one exclusive OR gate. Okay. So if you take 1 and 1, XOR का output क्या? 0. Again this is the first clock output. Again 1 and 1, what is the XOR gate का output? 0. Again 0 1, XOR gate का output क्या होता है sir? 1. These 2 bits you should, remaining to shift it. That's all. So what is the right answer? 100. Okay, option D, option D. 0 and 1 will give you 1 and these 2 bits will be shifted. Is it okay? बहुत सारे लोग C क्यों दिया? क्या हुआ? What happened? See here, we started with 111, 1 XOR operator. It is not XOR nor XOR. 1 1 hai to it will give 0. These 2 bits will be shifted. Fine. Then 1 1 aya. 1 1 is exclusive OR operation. It will give 0 and 0 1 will be shifted. Then 0 1 XOR is 1 and 0 0 shifted. What is the problem in this? Okay. Chalo. Next question. You can try at least this question. Another question from the shift registers. I think around last 20 years mein in the GATE, almost every single question is solved in this class of the sequential circuits. As many as possible I am trying to solve. Some questions we solved anyway in the regular course. I don't want to repeat the questions. What is the answer? You have a 4-bit shift register circuit. This is this shift register, right shift register, A to B, B to C, C to D. If the present state of the shift register is 1101, initially it is started from 1101. How many clock pulses required to reach the state of 1111? Let's do it. 1101. We have taken XOR of first and last. Okay, XOR of the first bit and last bit. If both are same, you get 0. Both are same, you get 0. And remaining 3 bits shifted. Both are different, 1. Both are same. Both are same. Both are same, you get 0. Both are different, you get 1. Both are different, you get 1. Both are different, you get 1. Again both are different, you get 1 and shifted. So how many clocks are required? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 clock pulses. It requires 10 clock pulses to get your required output. Okay. Very good, very good, very good. Let's move. So stay motivated up to the end of the class, guys. We are now entering into the counters. So flip flops is completed, registers is completed. We stayed up to 2 hours. You can see this is like a quick revision. So whatever sequential circuits you studied in 20 hours is just revised in 2 hours. Okay, so now we are moving to the next and the important topics. Not only counters, here we discuss the any synchronous design. So काउंटर्स में बेसिकली क्या क्या होता है, थोड़ा सा थ्योरी डिस्कस करेगा. काउंटर्स में क्या क्या होता है सर? रिपल काउंटर होता है, सिंक्रोनस काउंटर विल बी देयर. रिपल काउंटर में क्या होता है सर? क्लॉक इज अप्लाइड टू ओनली वन फ्लिप फ्लॉप एट ए टाइम. इसमें नॉन बाइनरी काउंटर भी होता है, वेर एवर क्लॉक इज अप्लाइड दैट इज LSB. सो रिपल काउंटर एंड अनदर इज सिंक्रोनस. सिंक्रोनस वी कैन डिजाइन विथ एनी फ्लिप फ्लॉप फॉर एनी काउंटिंग सीक्वेंस. एक पॉइंट इंपॉर्टेंट क्या, रिपल काउंटर में आपने Q इज गिवन टू नेगेटिव एज ट्रिगरिंग, आपको अप काउंटर मिलेगा अगर Q इन द ऑल फ्लिप फ्लॉप्स इन टॉगल मोड. आप किसी भी फ्लिप फ्लॉप को टॉगल मोड में कनेक्ट कर सकते हैं. टॉगल मोड का मतलब क्या सर? Qn+1 इक्वल टू Qn बार. ठीक है. सो फॉर एग्जाम्पल, चलो आपको चाहिए तो just a minute. So let's take this 4 flip flops. Okay. So suppose you take SR flip flop, JK flip flop. JK में दोनों इनपुट्स 1 है तो it will work like a toggle mode. Toggle mode of all the flip flops. Qn+1 equal to Qn bar. Okay. टॉगल मोड में आपका फ्रीक्वेंसी क्या होता है सर? F0 इक्वल टू F clock by 2 होता है. दैट इज बिकॉज इफ योर क्लॉक इज लाइक दिस, योर आउटपुट विल बी टॉगलिंग ऑन एवरी क्लॉक. सो टाइम पीरियड विल बी डबल्ड एंड फ्रीक्वेंसी विल बी हाफ. सो टी फ्लिप फ्लॉप में टॉगल मोड में कैसा कनेक्ट करेगा सर? इफ यू मेक टी इक्वल टू 1, Qn+1 इक्वल टू Qn बार. SR को कैसा कन्वर्ट करेगा सर? हियर यू शुड कनेक्ट लाइक दिस. Then SR is also in the toggle mode. You can write the characteristic equation and check it. For D flip flop, this is the toggle mode. सारे flip flops toggle mode में connect कर सकते हैं. So अभी देखो, ठीक है, काउंटर्स पे रिपल काउंटर में ऑल फ्लिप फ्लॉप्स टॉगल मोड में कनेक्ट करके एक फ्लिप फ्लॉप को हम क्लॉक डायरेक्टली देता हूँ, बाकी फ्लिप फ्लॉप्स को क्या, एक फ्लिप फ्लॉप का आउटपुट दूसरा फ्लिप फ्लॉप का इनपुट में देता हूँ. सो इस केस में Q नेगेटिव एज दिया तो अप काउंटर, Q और पॉजिटिव एज ट्रिगर्ड फ्लिप फ्लॉप्स ले लिया तो डाउन काउंटर होता है. Q bar is given as the clock. Okay, Q bar is given as the clock and नेगेटिव एज है तो ये भी डाउन जैसा काम करेगा. Q bar and पॉजिटिव एज ट्रिगर्ड ले लिया तो अप जैसा काम करेगा. सो हियर इसमें ध्यान से देखो, हम शॉर्टकट के लिए सेम Q and पॉजिटिव सेम ले लो, Q bar and नेगेटिव सेम ले लो. सेम का मतलब लाइक माइंडेड. Q bar and पॉजिटिव and Q and नेगेटिव अपोजिंग ले लो टू रिमेंबर. सो अपोजिंग है तो आपको अप आएगा, सेम है तो आपको डाउन आएगा. दिस आर द 4 कॉम्बिनेशंस इन द रिपल काउंटर. सो रिपल काउंटर का डिजाइन कैसा होता है सर? आई थिंक आई हैव दैट डिजाइन इन माय. ठीक है, चलो. So this is the example of the ripple counter. Okay, output of one flip flop connected as input to the next, output of one flip flop connected as input to the next. Here सारे flip flops toggle mode में connect किया. Q0 is negative edge triggering and Q0 is connected as a clock. First flip flop को clock directly देता हूँ, ये इसको clock, ये इसको clock connect किया तो this will work like a up. ये नेगेटिव के जगह में पॉजिटिव ट्रिगरिंग ले लिया तो डाउन जैसा काम करेगा. दिस इज व्हाट वी कॉल रिपल काउंटर्स. इसमें प्रोपगेशन डिले क्या होता है सर, n टाइम्स टीपीडी. प्रोपगेशन डिले इज इक्वल टू n टाइम्स टीपीडी होता है. ठीक है, दैट इज बिकॉज वंस दिस चेंजेस, वंस दिस चेंजेस, वंस दिस चेंजेस. इसमें क्या दिक्कत है सर, प्रोपगेशन डिले ज्यादा होता है. दूसरा दिक्कत क्या होता है सर, व्हाट इज द अदर डिसएडवांटेज इन द रिपल काउंटर्स इज it can contains the decoding errors due to transient states which we avoid by strobe signal. Okay, so decoding errors means when all flip flop bits are not changing at a time, if one bit is changing at a time, one state to another state mein beech mein transient states will occur. So these are the about your asynchronous or ripple counters. Here you don't give what we call any extra logic circuitry. It's a simple to design, but it requires more propagation delay. So similar to asynchronous, you can have synchronous. Synchronous में क्या होता है सर, सारे flip flop को clock एक ही बार देता हूँ. We will give flip flop for all flip flops, clock will be applied at a time in synchronous, and we will design it according to our requirement. Leave it. चलो. Here for all flip flops we give the clock at a time, and here what is the propagation delay is equal to generally 1 TPD. We should consider the setup time also, or your time period of the clock should be greater than or equal to TPD plus T setup. The frequency of the clock should be less than or equal to 1 by TPD plus T setup. Setup time, hold time, etc. we will be studying in your flip-flop delay calculations and all, clock timings, etc. General, if you don't have clarity about it, you can watch my regular videos. चलो, problem शुरू करेगा मैंने. Sequentially कैसा डिजाइन करना है, etc. Suppose see here, synchronous डिजाइन करना. For example, I will take one example for fastly. Okay, design a synchronous counter to count 0 to 130 using, somebody ask me ना how to use the excitation table. अभी दिखाता हूँ. ऐसा आप डिजाइन करना चाहिए तो क्या डिजाइन करना. See here, डिजाइन का प्रोसेस क्या. First you should take one table like this, present state, what is the next state, आपको जो चाहिए ना वो लिखना चाहिए यही पे. इसके बाद इनपुट्स क्या देना, that is here Q1 Q0, log to the base 2 number of states we should take the number of flip flops. इनपुट में क्या देना सर, D1 D0. So here 0 0 0 1 1 0 1 1, चार पॉसिबिलिटीज ले लो. Here क्या लेना, 0 का according to my requirement, what is the required design is 2. Next 0 का next 2, 1 का next क्या सर 3, 2 का next क्या सर 1, 3 का next क्या सर 0. So now you understand the use of excitation table. Somebody asked me earlier ना, so here क्या करना है, excitation table. That is presently ये मेरा पास है तो next ये चाहिए तो इनपुट में क्या देना. डी फ्लिप फ्लॉप में इजी क्या सर, एक्साइटेशन टेबल सेम एज नेक्स्ट स्टेट. नेक्स्ट स्टेट में जो चाहिए वो एक्साइटेशन टेबल में देना. दैट इज Qn प्लस 1 इक्वल टू डी. सो अभी डी का इक्वेशन लिखो. क्या होता है सर, इट इज 1 फॉर 2 केसेस. इफ यू सॉल्व दिस बाय के मैप और एनी मेथड यू गेट Q1 बार. डी नॉट का इक्वेशन लिखो. इट इज 1 फॉर दीज 2 केसेस, दैट इज Q1 XOR with Q0. That's all. So you can take 2 flip flops. Okay. So D1, D0, Q1, Q0. Okay. So D1 is equal to Q1 bar. That's all. Okay, this is how you design any counter. Simple 1 minute में मैंने दिया पूरा सिंक्रोनस में कैसा डिजाइन करना काउंटर, किसी भी काउंटर है तो इसका एक्साइटेशन टेबल लेना चाहिए, किसी भी फ्लिप फ्लॉप से ले सकते हैं, whatever the design, whatever the sequence you require, use that. Okay, shall we move to the problems? Okay, let's start the first problem. Yes, do the question, try the question and give me the answer. Okay guys, tell me, try this question. Okay, I will do it. Very good. Listen. Okay guys, we are back, don't worry. Okay, I restart the system. सिस्टम तो हैंग हो गया, सिस्टम पे संडे का मूड पे है, सो 2 घंटा हो गया ना, सिस्टम तो सो रहा है, सो सिस्टम तो भी छुट्टी चाहिए सिस्टम को, सो मैं तो फिर एक्सप्लेन करेगा, डोंट वरी अबाउट इट। ओके, फिर एक और बार एक्सप्लेन करेगा, इसमें क्या दिक्कत है। देखो अभी तो ऑडिबल है ना, एक बार कंफर्मेशन दीजिए, मैं तो ये भी कमेंट बॉक्स देखता हूँ, बताओ ऑडिबल है ना। ओके चलो, सो देखो भाई अभी क्या करना चाहिए। फर्स्ट क्लॉक कहाँ अप्लाई किया, क्लॉक कहाँ अप्लाई किया, यहीं पे अप्लाई किया, ये आपका एलएसबी होता है, फर्स्ट पॉइंट। नेक्स्ट दैट इज ये इज योर एलएसबी। सेकंड पॉइंट क्या सर, हियर शुरू किया मैंने नेगेटिव एज ट्रिगरिंग में, क्यू इज कनेक्टेड एज द क्लॉक अप काउंटर, ठीक है, सेकंड पॉइंट तो भी हो गया। थर्ड पॉइंट क्या, 0 to 5 काउंट करना, 6 आएंगे तो क्लियर देना चाहिए, 6 का मतलब 110 आएंगे तो क्लियर करना चाहिए। इन द फर्स्ट 6 स्टेट्स 0 to 6, these two are 1 1 only for 6, these two are 1 1 only for 6, ठीक है। सो ये 1 1 हुआ तो, ये 1 1 हुआ तो क्लियर देना चाहिए। सो फॉर दैट इफ इट इज ए एक्टिव हाई you can take AND gate, if it is a active low you can take NAND gate. Why only these gates sir? Because these gates will give you, for example here 1 1 is only condition where you get 1, for other conditions you don't get 1. If you take OR also 1 1 will give 1, but OR will give 1 for other cases also. So to avoid that it should be clear only for 1 1, so AND gate can be taken. NAND for active low, because it is active low you can take NAND. If you send this bubble backside, C bar and B bar, it will become, it is a OR gate also. So why you took OR gate only sir, why not AND gate? AND gate also will clear, but here active low, okay, C bar B bar 0 0 mein it should clear. Then you will get the doubt, sir can I take AND gate 0 0 mein it will also clear? No, 0 0 not only for 0 0 it will clear for other cases also. So active low mein if inputs are complemented you should take only OR gate, okay, it should give clear only for that condition, not for other conditions. चलो नेक्स्ट वाला क्वेश्चन, ये वाला मैचिंग कर लो आप लोग, डू द मैचिंग गाइस। Choose the correct one among the alternatives of A, B, C, D after matching an item in the group 1 with the most appropriate in the group 2. चलो शुरू करना। ओके, शिफ्ट रजिस्टर, सीरियल टू पैरेलल कन्वर्शन, काउंटर एंड डिकोडर क्या होता है सर, एड्रेसिंग इन द मेमोरी। काउंटर तो फ्रीक्वेंसी डिवीजन करता है बस। P throw 3 3 1 2, very good, correct. Next question, so try this question, give a try and tell the answer. गिव ए ट्राई, टेल मी द आंसर। ये तो बहुत आसान से हो जाएगा, जस्ट 1 मिनट का क्वेश्चन है ये। कमेंट गाइस, 1 मिनट पे हो जाएगा ये वाला क्वेश्चन। हैदर अली, मैं तो प्रॉमिस किया ना कल क्लास में, आज रात तक देता हूँ। ओके, बिफोर कमिंग टू योर फ्रेंड टुमारो आई विल डेफिनेटली गिव यू। वेरी गुड, ऑप्शन बी, ऑप्शन बी इज रॉन्ग आंसर। ओके, ये तो टॉगल मोड में सारे फ्लिप फ्लॉप्स तो कनेक्ट किया, सही बात है। सो सी हियर क्यू नॉट आपका एलएसबी है। बताओ आप अप काउंटर और डाउन काउंटर, क्यू बार एंड पॉजिटिव। यस 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 यस, आई एम सॉरी, क्यू बार एंड पॉजिटिव है तो अप काउंटर, ये तो पॉजिटिव इज ट्रिगरिंग एंड क्यू बार इज द क्लॉक, लाइक ओके ऑपोजिंग गए तो अप है ना। सो 3 के बाद क्या होता है 4। करेक्ट 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 करेक्ट, रिपल काउंटर अप काउंटर। नेक्स्ट, ये वाला ट्राई करके आंसर बताओ। So it has given you the feel of total revision of the sequential circuits. Am I correct or not? पूरा sequential circuits थोड़ा सा कम टाइम पे we have done. Okay, I have done the problems not very tough because हमारा रेगुलर क्लास में हमने किया बहुत टफ वाला क्वेश्चंस, क्रिटिकल वाला क्वेश्चंस रेगुलर क्लास में किया। ऐसा क्वेश्चंस ले लिया तो अभी 3 घंटे में एक क्वेश्चन में आधा घंटे चलेंगे तो ज़्यादा क्वेश्चंस नहीं करेगा। सो इसका इंटेंशन, माराथन सेशन का इंटेंशन क्या, पूरा रिवाइज करना सीक्वेंशियल का, एक ओवरव्यू देना। इसलिए मैंने इतना टफ क्वेश्चंस तो नहीं ले लिया, रेगुलर क्लास देख लूंगा मेरा सीक्वेंशियल सर्क्यूट में, यू विल गेट द बेस्ट पॉसिबल क्वेश्चंस, ऑल द डिफरेंट मॉडल क्वेश्चंस, मोनोस्टेबल मल्टी वाइब्रेटर का क्वेश्चंस होता है, स्टेट मशीन्स का क्वेश्चन, सारे क्वेश्चंस हमने किया इन द रेगुलर क्लासेस। Okay, read the question, try to answer. Yes, the last half an hour of your total class. So let's see how many of you will win up to the end of the class. So मैं मंडे, कल मंडे है ना, मंडे से ये प्लान कर रहा हूँ आपके लिए। नेक्स्ट वीक से, नॉट दिस मंडे से, दिस मंडे से क्या होता है सर, लॉजिक फैमिली शुरू करेगा, that is for EC students. Next Monday से, so this Monday, tomorrow only for EC class ना, so I will think maybe tomorrow I will plan 7 PM से, क्योंकि अंकित सर का क्लास तो इलेक्ट्रिकल मशीन्स का, that is for electrical students. My class तो logic family is for EC students. So if I take it at 7 PM, it will be convenient, I am thinking. So I will update you in the Telegram channel and all. So that is about next week. परसों, आफ्टर दैट नेक्स्ट वीक फ्रॉम आई थिंक 14 और 15 आई विल स्टार्ट नेटवर्क क्रैश, पूरा नेटवर्क का क्रैश चलेगा। 30 to 40 आवर्स में मैं कंप्लीट करेगा आपका पूरा सिलेबस, नेटवर्क्स का क्रैश इन हिंदी और इंग्लिश मिक्सड लैंग्वेज पे, इंग्लिश में। एवरी स्टूडेंट कैन अटेंड दिस, दिस इज मे बी फ्रॉम 15th December आई एम प्लानिंग। These are the initiatives, free initiatives. And one more thing guys, for those who attended my networks class, Monday onwards or Tuesday onwards I am planning free special classes. First classes maybe 4 class I will take on quick revision of the transients, revision in the sense सारे transient का problems जैसा DBP जैसा difficult problems I will solve in this sessions. Okay, this maybe I will announce the time, maybe tomorrow onwards. First I will take one session on transients, then on AC analysis I will take the similar session, then for on other cases also I will take. So this month we will take free classes more, so don't worry. So tell me the answer guys. Yes, पटनायक ट्रांजिएंट का स्पेशल क्लास में तो प्लान कर रहा हूँ, मे बी कल और परसों से प्लान करेगा। So see here, 2 D flip-flops are shown below, are connected synchronous counted that goes the 0 1 3 2. So आपका सीक्वेंस क्या चाहिए सर, 0 1 3 2, ये वाला सीक्वेंस काउंट करना चाहिए। सो D0 एंड D1 रेस्पेक्टिवली। ओके, इनपुट कनेक्टेड। सो हमारा D0 में क्या कनेक्ट किया, जस्ट डिजाइन करना चाहिए। मैंने एक एग्जांपल दिया ना, सेम मॉडल, सो यही पे करेगा मैंने। सो प्रेजेंट स्टेट, आपको नेक्स्ट क्या चाहिए, इनपुट्स क्या देना, Q0 Q1, इनपुट्स में क्या देना, D1 D0 D1। ओके, सो प्लीज लिसन हियर। ओके, एग्जामिनर ले लिया Q1 Q0 ना, हम भी Q1 Q0 लेता हूँ। सो 0 0 0 1 1 0 1 1 4 पॉसिबिलिटीज है। नेक्स्ट स्टेट में क्या होना चाहिए सर? 0 का नेक्स्ट स्टेट, सीधा फिगर एग्जामिनर दिया, 1 का नेक्स्ट स्टेट 3, 2 का नेक्स्ट स्टेट 0, 3 का नेक्स्ट स्टेट फिर 2। सो इनपुट में क्या देना सर? 1 1 0 0 1 0। डी फ्लिप फ्लॉप दिया तो आपका काम बहुत आसान है। सो D1 क्या होता है सर? इट इज 1 फॉर दीज टू केसेस। In these two cases, how to write the expression? Q1 bar Q0, Q1 Q0, that is Q0. Here what is the expression? It is for these two, Q1 bar. So D0 must be Q1 bar and D1 must be Q0. इतना आसान से कर सकते हैं आपका क्वेश्चन, आपका कॉन्सेप्ट सच्ची से हो गया तो। ओके, सो फाइन, लेट्स मूव। Mamata, I am planning for that. I will inform, I will talk to students. I mean, I will conduct one poll for that quiz. So, मैं तो announce करेगा. I will conduct a poll and accordingly I will announce the timings for that quiz. Okay. चलो guys, next question. Yes, ये वाला क्वेश्चन तो असली क्वेश्चन है, सीक्वेंशियल वाला, सिंक्रोनस वाला क्वेश्चन में। लेट्स डू दिस क्वेश्चन। आप लोग ट्राई करो, थोड़ा सा ट्राई करो, मैं तो आई विल एक्सप्लेन इट देन। कितना क्वेश्चंस बाकी है? अभी हमने 2-3 क्वेश्चन बस, इसके बाद क्लास बंद करेगा। सो इसके पहले ये क्वेश्चन पे वापस आएगा, पहले ये क्वेश्चन कर लो। ये लास्ट 2 क्वेश्चंस करके लास्टली वो क्वेश्चन करेगा। सो 3 क्वेश्चन बाकी है, इसके बाद क्लास बंद करेगा। सो ट्राई दिस क्वेश्चन फर्स्ट गाइस। सो द सर्क्यूट शोन हैज ए जेके फ्लिप फ्लॉप एक्टिव लो एसिंक्रोनस रीसेट। ओके, ठीक है, ये तो क्लियर बार है। एसिंक्रोनस का मतलब क्या? इट विल इंस्टेंटेनियसली क्लियर विदाउट द हेल्प ऑफ क्लॉक। ओके, सो द काउंटर करस्पॉन्डिंग टू द व्हाट इज द काउंटर? अप काउंटर और डाउन काउंटर? पहले देखो, इसमें बबल दिया ना, नेगेटिव एज ट्रिगर ले लो। नेगेटिव फर्स्ट पॉइंट क्या होना चाहिए? एलएसबी कहाँ पे? ये आपका एलएसबी होना चाहिए, QA आपका LSB। सेकंड पॉइंट नेगेटिव एंड Q अप काउंटर। थर्ड पॉइंट फीडबैक गेट आइडेंटिफाई करो। फीडबैक गेट में हियर C कनेक्ट किया, हियर ये कनेक्ट किया। सो दैट इज you see here it counts from 0 0 0 0 0 1 0 1 0 0 1 1 CBA 1 0 0 1 0 1। ये दोनों 1 हुआ तो it will immediately clear. So it is mod 5 counting from 0 to 4. So mod 5 up counter। ये हमारा टेक्निक है, 3 स्टेप के आपको किसी भी काउंटर का आंसर आएगा। सो स्टार्ट फ्रॉम what is that? LSB क्या? QA। then find up counter और down counter। इसके बाद feedback gate identify करो। so when these two are ones it will give clear bar। so दोनों 1 कब होता है सर? 1 1 1 0 1 पे। बस mod 5 up counter। is it okay? yes, very good, very good, very good, excellent। let's go। ये वाला क्वेश्चन ट्राई करके आंसर बताओ। 8 तो विजिबल नहीं है तो मैं तो थोड़ा सा जूम करेगा। दिस इज द रियल गुड क्वेश्चन, दिस इज द रियल गुड क्वेश्चन। आप लोग ट्राई करके आंसर बताओ। गिव योर आंसर. दिस वाला क्वेश्चन वेरी गुड क्वेश्चन, प्लीज ट्राई, प्लीज रीड. इसमें क्या यू विल लर्न वन न्यू थिंग, दैट इज पेशेंस इज द की टू सॉल्व योर आंसर. पेशेंस से पढ़ो, आपको आंसर मिलेगा. रीड द क्वेश्चन विथ पेशेंस, never afraid of the question. That is the simple trick of the question. So the digital logic shown in the figure satisfies the given state diagram when Q1 is connected to input A. अगर Q1 ने इनपुट को कनेक्ट किया तो इट विल वर्क लाइक दिस. ठीक है, 0 दिया तो 0 में, 1 दिया तो यही आएगा, ऐसा काम करेगा. सो नाउ व्हाट इज द, सपोज XOR गेट इज रिप्लेस्ड बाय XNOR. विच ऑफ द फॉलोइंग ऑप्शंस प्रिजर्व्स द स्टेट डायग्राम. फिर भी सेम काम करना चाहिए तो क्या करना. बहुत आसान क्वेश्चन है, बहुत आसान से हो जाएगा. लुक्स कॉम्प्लेक्स, क्वेश्चन लुक्स वेरी कॉम्प्लेक्स. स्टेट डायग्राम है, ये क्या कर रहा है, ऐसा सोच किया तो यू विल ट्रबल. थिंक इजीली, सिंपलेस्ट वे टू सॉल्व द क्वेश्चन. सॉल्व द क्वेश्चन सिंपली. सी हियर XOR, firstly if you connect, if you connect here Q1 and S to the XOR gate, you get Q1 XOR with S. Now what he has done is XNOR किया, S connect किया. Here क्या connect करना, बस XNOR का एक इनपुट कॉम्प्लीमेंट किया तो फिर XOR आएगा वापस में. So you can connect, what is that, इनपुट A में Q1 bar. So what will you get here, Q1 bar XNOR with S. चलो, Q1 bar into S plus Q1 bar into S double bar. This is A into B plus A bar B bar. आपको क्या मिलेगा, this is XOR. Just आपका जॉब तो no, don't worry about this. How to convert XNOR, how to make XOR using XNOR. If you know that, it is sufficient. ये तो बहुत बेसिक का क्वेश्चन है. सो ये में क्या कनेक्ट करना, नहीं, yes to be as it is लेना चाहिए. If any one of the input is complemented, XNOR will again work as a XOR. That is the simple basic you should know. No need to know the how it is working, all these things, nothing is required in this question. Very good. चलो next वाला question. Try this question. Give a try. आपको किसी क्लास में मारतन चाहिए तो बताओ. नेटवर्क्स और डिजिटल में काफ़ी टॉपिक्स में आपको सर इसमें मारतन चाहिए सर बताओ, मैं तो करेगा. मे बी नॉट नेक्स्ट वीक, आफ्टर दैट वीक. ओके, सो आई विल मेक ए फ्री मारतन फॉर यू, डोंट वरी. अकॉर्डिंग टू योर नीड आई विल मेक इट. सो ट्राई दिस क्वेश्चन. This is an easy question. You can do it easily. Give a try, guys. Give a try. सो ट्राई द क्वेश्चन, टेल मी द आंसर गाइस. पहले आपका ऑब्जर्वेशन ऐसा होना चाहिए, ये दो जे फ्लिप फ्लॉप्स है ना, जेके फ्लिप फ्लॉप, इसका आउटपुट डायरेक्टली कनेक्टेड, इसका आउटपुट कॉम्प्लीमेंट से कनेक्ट किया, इसका मतलब इट इज वर्किंग लाइक ए डी फ्लिप फ्लॉप. इट इज वर्किंग लाइक ए डी फ्लिप फ्लॉप. वर्किंग लाइक ए डी फ्लिप फ्लॉप. एक और माराथन सेशन है ऑसिलेटर्स का, दैट इज बाय कामेश सर. यू कैन अटेंड दैट. आई थिंक टुडे 3-4 विशाल सर का भी है, रमन सर का भी है. सारे माराथन सेशंस आर देयर. विच एवर यू टॉपिक यू आर इन द नीड, attend all the marathon sessions are going to be very good. Okay, so let's see here this one, q1 q2. Okay, that is here it is. Why this condition can be true only when it is a D flip flop mode में connect किया तो. Here also it is D flip flop mode only. Here variable connected इसका complement, but here q2 bar q2. Here also it is working like a D flip flop. That is here you should connect one inverter. This is nothing but Johnson counter, right? Johnson counter है तो हमारा काम बहुत आसान है सर. 0 0 से शुरू किया तो 0 बार आएगा, 1 0 बार आएगा, 1 बार आएगा, 1 बार आएगा 0. So now what is the answer? Q1. Q1 का आउटपुट सीक्वेंस निकालना. सो Q1 का आउटपुट सीक्वेंस इज 0 1 1 0 0 0 1 1 0 0. बस सिंपली यू कैन डू इट. सो एनी सीक्वेंशियल सर्क्यूट का क्वेश्चन नाउ यू विल बी एबल टू सॉल्व इट वेरी फास्टली. वेरी गुड. चलो नेक्स्ट क्वेश्चन. राइट, नाउ वी विल बी बैक टू दिस क्वेश्चन which I left earlier. See, मैंने already I told you when we discussed the modulus of the counter, if examiner gives synchronous clear, the clear will be applied in the next clock. Then in that case, that count should be considered. If simply said clear or asynchronous clear, clear will be done immediately. Okay. So last question for today's class, guys, this one, right? What are the counting states of Q1, Q2 for the counter shown in the figure? Okay. So let's start. सो पहले मैं फिगर से डायरेक्ट एनालिसिस किया तो क्या होता है वो एक्सप्लेन करेगा. इसके बाद 2-3 मेथड में इस वाला क्वेश्चन को कैसा करना, ये मेथड सारे सीक्वेंशियल सर्क्यूट्स में अप्लाई कर सकते हैं. सो लेट्स डू इट. आई विल शो यू हाउ टू डू इट डायरेक्टली फ्रॉम द फिगर. इसके बाद क्या करेगा, हाउ टू सॉल्व बाय डिफरेंट मेथड्स विच यू कैन अप्लाई इन एनी सीक्वेंशियल सर्क्यूट प्रॉब्लम. सो लिसन हियर. Why it is called modular counter? Because it will repeat after n number of clock pulses again and again. Sometimes examiner asks you like this, find the output at 345 clock. You need not count all those 345. You should check how many clock pulse के बाद it is repeating. Then you should use mod operator to find the original answer. So regular class में we discussed that also. Now come back. So Q1, Q2, right? Initially 0 ले लो. Always analyze the synchronous counter or synchronous design from the right side. By the time you apply the clock, what is the existing input that should give your output? After that, if input changes, it should not reflect in the output, it should reflect in the next clock. So apply the clock, for example. Now rightmost से क्यों करना sir? To avoid the confusion. Because leftmost से किया तो once you change this output, then you will confuse whether to take this value or the changed value. So to avoid that, always what is the point? By the time you are applying the clock, what is the input present? That will give you the output. So one method is directly analyze from the figure. ये 0 है तो ये 1 होता है, ये 1 यहीं पे आएगा. ठीक है. So now मैंने फर्स्ट क्लॉक अप्लाई किया तो जेके फ्लिप फ्लॉप को, इसका इनपुट में क्या है सर? ये 0 है तो ये क्या है सर? 1. ये 1 1 पे है, दोनों 1 1 है तो क्या होता है सर? टॉगल हो जाएगा. टॉगल ऑफ प्रीवियस वैल्यू. हियर आल्सो व्हाट इज द इनपुट? 1 1. टॉगल हो जाएगा, इसका मतलब 1 0. ठीक है सर, 1 0 आया. सो नाउ क्या होता है सर? दिस इनपुट इज रिप्लेस्ड बाय 0, दिस इनपुट इज रिप्लेस्ड बाय 0 0. Apply the second clock pulse. Systematically I am going. आपका इनपुट में क्या सर? अभी 0 1 0 1 आएगा. आपका इनपुट में क्या सर? What is the input you are having sir? 0 0. आउटपुट में no change. 1 0 आएगा. Okay. Next, for third clock pulse, this 1 will go back here. Okay. And this which one? this 0 will come here. Okay, so now listen here, again it is 1 1. So for the third clock pulse, what is the input? 0 1, you get 0, okay, and 1. What is the input here? 1 1 means toggle. Toggle means you get 0 1. We started with both zeros and we ended with both zeros after 3 clock pulses. So what is the examiner sequence required? Q1 Q0 is 0 0. इसके बाद क्या होता है सर? 1 1 1 0 0 0. Check 0 0 1 1 1 1 1 0 0 0. Sir, but this method is not suggestible in exam because chance of confusion is there. To avoid that, you can go by another method. What are the inputs for your J1 and K1? J1 is Q2 bar, K1 is Q2 bar. J2 Q1 bar, K2 1. Let me use them. See here, I will give you different way to solve the same question. Let's try. Listen here. Let's try with the help of characteristic equation. Second method to solve the same question. J Qn bar plus K bar Qn. आपका Q1 का इक्वेशन क्या होता है इन द नेक्स्ट स्टेट? J Qn bar, that is Q2 bar Q1 bar plus K Q2 bar whole bar into Q1. J into Qn bar plus K bar Qn. Okay, so क्या होता है सर? Q2 bar Q1 bar plus Q2 Qn. It is Q2 XNOR with Qn. ठीक है ना? Right. Next, what about the Q0 next state equation? J Qn bar, J क्या? J2 Q1 Q2 ना? 1 minute. Q1 Q2, right. Okay, J Qn bar plus K bar Qn. Okay, so this will give you Q1 into Q2 bar. ऐसा क्यों कर रहे हैं सर? सिंपल, इसका इक्वेशंस आने के बाद आपका काम इतना आसान होता है, आपका प्रेजेंट और नेक्स्ट, ठीक है. सो Q0 Q1 ले लो, नहीं तो Q1 Q2 ले लो, नेक्स्ट का Q1 Q2 ले लो. नेक्स्ट का इक्वेशन क्या सर? अभी देखो, दोनों का XNOR, इसका Q1 Q2 बार. सो इनिशियली 0 0 से शुरू किया तो XNOR क्या होता है सर? 1. Q1 इंटू Q2 बार 0. इसमें XNOR क्या होता है सर? इसमें XNOR क्या होता है सर? 0. देन Q1 इंटू Q2 बार 1. कुछ गलत किया? Q1 इंटू, just a minute, J Qn bar, J is Q1 plus K bar into Qn. Sorry, here Q1 bar 0 into Qn. Just a minute guys, इक्वेशन कुछ गलत नहीं है ना? In the figure, it is Q1 bar. I am sorry. Okay. Now it is fine. So 0 bar into 0 bar क्या होता है सर? 1. So दोनों का XNOR किया तो again you get 1. Then these two whole bars क्या होता है सर? 0. सो प्रेजेंट 1 0 ले लो, नेक्स्ट क्या होता है सर, दोनों को एक्सनॉर किया तो 0, Q1 बार इंटू Q2 बार भी 0. Like that you can do it. This is one method to do the question. If you are not satisfied with this also, no problem. There is another way to solve this question. Sorry. This is the method, the last method of the class for the last question, which will be help you. I mean, this is the method which you can use in all the questions. This is the easiest method. Present state, आपका इनपुट्स क्या डिजाइन किया तो नेक्स्ट स्टेट और इनपुट्स एनालिसिस करना चाहिए तो इनपुट्स J2 क्या, K2 क्या, J1 क्या, K1 क्या और नेक्स्ट स्टेट क्या. ठीक है. सो आपका Q1 Q2 नहीं तो Q1 Q2 ले लिया ना, J1 K1 J2 K2. Okay, then what is the next state of Q1 Q2? J1 is Q2 bar, K1 is Q2 bar, J2 Q1 bar and 1. So presently 0 0, Q2 bar 1 1 होता है, Q1 bar 1 1 होता है. 1 1 दिया तो फ्लिप फ्लॉप क्या करेगा सर, टॉगल करेगा, सो इट विल बिकम 1. 1 1 दिया तो फ्लिप फ्लॉप क्या होता है सर, टॉगल, सो Q2 विल ऑल्सो टॉगल. सो प्रेजेंटली 0 0 है तो आपका नेक्स्ट क्या मिलेगा सर, 1 1. नेक्स्ट टेक 1 1. According to the given figure, what are your inputs? Q2 bar is 0, 0, Q1 bar is 0 and 1. Now 0 0 दिया तो it will be no change. 0 1 दिया तो it will become 0. Then you take this value. Here you should not take all. Whatever you get here, that you should take here. 1 0. What is Q2 bar? 1. What is Q1 bar? 0. What is 1? So here 1 1 means toggle, Q1 will toggle. 0 1 means it should be 0. Same method. This is the best method without any confusion. This is the present state. What are the inputs according to the figure? What is the next state based on the truth table of the flip flop? That's all. Is it fine? All your questions are done. Okay? So thank you for your time. Thank you for listening. I hope you enjoyed the session. All the sequential problems I tried to solve it in the available time of what we call 3 hours. So it's like a quick revision for you. So you can get the notes from our Telegram channels, guys, and you can follow and subscribe our channels for more and more number of this kind of videos for you guys. So thank you very much, guys. Love you all. Bye bye. We'll meet with the few more exciting sessions in the next sessions. Thank you. Thank you very much. Bye bye. Okay. Bye bye. Thank you. Love you all.